Okay, so PixInsight. If you have dabbled in the hobby of astrophotography, whether you use a dedicated astrophotography rig or you come from more humble beginnings with something like a smart telescope like the C-Star S50, you probably have heard of PixInsight as, let's say, the ultimate tool to post-process your images in the hobby. And a lot of people are turned away from PixInsight due to its high price. It's a one-time cost of 300 euros right now, and or due to its reputation as having an incredibly difficult learning curve, extremely steep. Those are usually the two reasons that make people go away from PixInsight. The price is something I cannot do much about, except tell you that I bought PixInsight, I think it was 2015, something like that, and it is the single best and most used piece of equipment that I have used in the hobby, including all of the telescopes, cameras, filters, mounts that I've used. PixInsight is the one piece of equipment that is still with me now, that I'm still using constantly now, and it's repaid for itself over and over and over again, more so than any telescope or filter or camera that was more expensive than that. It truly is that good, and it is a tool that if you purchase, you will keep coming back to for years and years and years. As such, to me, 300 euros, it's honestly cheap. So that's the price of things. But that is something that you have to basically convince yourself or reach that decision on your own. Where I can help very actively is about the learning curve. I keep hearing PixInsight has a steep learning curve. It is extremely hard to use, etc., etc. But the truth is, when I process my images, and I'm very used to PixInsight, mind you, but when I process my images, typically, to process an image from zero or from a stacked image to a final image, it takes me on average maybe 20 to 30 minutes. And most of the tools that I use are fully automated tools. We live in an era where there are so many scripts and AI-powered processes in PixInsight that you can really follow the same process over and over again for all of your images and get amazing results with as little effort as possible. There's a reason why I named my channel Quiz the Lazy Geek, because I like to be lazy, and here lazy meaning efficient. And so there's this flow that I use that's 20 to 30 minutes long. I've already presented it on my channel, but what I haven't done is presented it in a way that a complete beginner to PixInsight, meaning you have never installed PixInsight before, you have no idea what you're doing, could go from knowing nothing about it to being able to process images extremely skillfully using my workflow, and you could learn that in just a couple of hours, hopefully. I don't know how long this video is going to be. It's probably going to be fairly long because I will go from the basics of installing PixInsight all the way to processing your images to the final image using what I would say is a very lazy workflow that gets you like 90% of the way there for 10 to 5% of the effort required. After that, if you want to learn more about PixInsight, there are amazing advanced tutorials available on YouTube or behind paid courses like the Adam Block courses, which are incredible, but they get extremely advanced. It's really to make the best of PixInsight. But I'm here to tell you that getting the basics of PixInsight right, and by basics I mean 90% to 95% of PixInsight right, it will take you only a couple of hours. And there is a 45 days trial available on PixInsight if you want to try it out. So if you're wanting to try out PixInsight and you just need to you have those 45 days to get used to it and to understand whether you want to actually purchase it or not, why not follow this video and, see what you can achieve. Now, just to be clear, this video is not sponsored by PixInsight or anyone for that matter. It's sponsored by me and by my Patreon supporters and channel members. Thank you so much, guys. And I do that just to share my knowledge because I'm really convinced that PixInsight is the best processing software there is in astrophotography, and it is a shame to not use it, or at least not try it once via the trial in a way that is efficient so you know what you're doing. Okay, with that said, that's a long intro, and I'll be covering multiple scenarios. I'll cover a one-shot color camera scenario with broadband imaging. I'll cover the scenario of a one-shot color camera used with dual-band narrowband filters. H-alpha oxygen 3, sulfur 2 oxygen 3, because those are extremely popular these days, especially in light polluted cities. I'm in Tokyo, Japan, so I live and image from an extremely light polluted city. And I will also cover the case of monochrome cameras using LRGB filters, as well as monochrome camera using HSO filters, so H-alpha, sulfur 2, oxygen 3 filters for narrowband. Again, it's excellent from a light polluted city like here in Tokyo. And so we'll have all of those scenarios covered, but honestly, you'll see, they all use the same workflow. And of course, before going to those workflows, I'll go through the basics of installing PixInsight and then getting used to this interface, all in this video. With that, let's get this show on the road, guys. Okay, so first, when you are getting into PixInsight, you will want to either buy the software outright, or you can also request a trial license. So you just want to go to pixinsight.com, you can go to licenses, and then request trial license if you want to request a trial, or purchase commercial license if you want to buy it outright. So a trial license, you'll need to put your email, first name, last name, address, etc., and submit that. You will then receive an email with your credentials to log into the website to download PixInsight, and then to also log into PixInsight once you've downloaded it. If you're buying it, you'll just buy the license and just follow the steps. Okay, so once you have your trial or your commercial license, what you'll want to do is go to Downloads, Software Distribution, and once you're there, it will actually ask you to log in. So please use the credentials that you just received from the PixInsight team to log in. And then you'll be on a page like this one, the PixInsight Software Distribution System. You want to go ahead and go down below, select the latest version, and install the version for your computer. It can be either Windows, macOS, or Linux. I've done tests in the past and I have confirmed that PixInsight actually runs considerably faster on Linux than it does on Windows, but since most people are using Windows, I'll be installing it on my Windows machine for today. So just click on it to download PixInsight for its latest version. And while you're at it, you may want to grab the Gaia DR3 SP set, those 4 files, which will be useful for a process that we call spectrophotometric color calibration, that lets you achieve exactly the right colors for any broadband, specifically broadband images that you have taken. So I would recommend just downloading those 4 files as well while we are at it. And if you are going to be using PixInsight in an offline environment quite a lot, you may also want to download this Gaia DR3 files. So from this 1 file to 16, and these can be used by PixInsight to look at the stars in your images and then determine what target your image was taken on. And that's very useful for a lot of processes in PixInsight. So you may want to download that if you are going to be using PixInsight in an offline environment a lot. For me, I'm using PixInsight in an online environment all the time, so I'm not downloading those because they do take a lot of space, but I'll still show you how to install those files if you need them. Okay, once we're done with the download, I would recommend creating a folder somewhere on your computer. For me, I created it under my documents, effectively. I called the folder Gaia, and then underneath I put 2 folders, Gaia DR3, where I can put the files that we just downloaded for Gaia DR3 here, in the case that you are going to be using PixInsight in an offline mode. And I'm also going to put the files that we downloaded from here, DR3SP, the small set, and I'm putting them in this Gaia DR3SP folder for now. The location doesn't really matter where you put that on your PC, just make sure that it's somewhere where you're not going to delete them or misplace them by mistake. So for me, I put them under Documents Gaia. Then we want to install PixInsight, so for now you just need to locate the installer, typically in your Downloads folder. And the installer looks like this, PI, Windows x64, etc. So I'm just going to double-click it to start with the PixInsight installation. So PixInsight installation is very easy. You just, at least on Windows, click on Install. I assume on macOS it's going to be very similar to any other macOS application installation. And once it's running, you can just let it do its thing until task completed successfully, and then we can click on Finish. Okay, now that we've installed PixInsight, we can run it. So I'll just go ahead and launch PixInsight for the first time, and it should be asking you for your license information, which would be your user identifier and your activation code. And you should have received that in your email, so you should be able to just input that. If you have any issues, you can click on Request Activation Codes. It should also be noted that there will be a folder that is going to be created on your computer. You can access it via this string of text. I'll put it down in the description. And in there, once you have activated PixInsight, you will get a license file that appears. And here we have this license file. You can make a backup of it if you need to reinstall PixInsight on the same computer. You can use this license file again and simply reuse it by putting it back into this folder if you ever lose it for whatever reason. Once you have everything ready, you'll be greeted by a screen like this with also this probably risky temporary folders. And you can just ignore that for now. And you can see we have this black window to the left. We're going to ignore that for now. You can click anywhere on the screen outside of the black window, or you can re-look at the black window using the tabs here on the left. There's a lot of things in there. I usually don't really use them, but they're there just so remember. You'll also likely be greeted with some PixInsight updates to apply via this little notification thing. So it's a good idea, first thing, to just apply them. So click on the notification, you'll get a window like this. It's gonna update a bunch of default stuff that comes with PixInsight, and it will ask you to restart PixInsight once it's ready. You can see it's just downloading whatever it needs. And once it's done, you'll get a notification. There you go. The packages have been downloaded. You can click on OK. And then you can just close PixInsight. And it will ask you, do you want to install the updates? And you can keep the Restart PixInsight here checked. Click on Yes. And now we'll have the latest version of PixInsight. After that's done, we're going to do the initial setup that you need to do with PixInsight, including repositories. And it is at this point that I will also start talking about modules that can be downloaded for PixInsight. Okay, anyway, for now we've done the updates, so I'm just going to click on OK. I get the same warning as before. PixInsight is back on track. We're there and we can go further now. So let's talk a bit about modules for PixInsight. There's tons of modules that are available for free a lot of the time for PixInsight in the form of scripts and processes. I'll go to what those are in a moment. And you can install them very easily using repositories that you add to PixInsight. There is in particular some modules that I highly recommend you get, and I'll just show you in the description a list of links to copy-paste, and we'll do that together in PixInsight. There's also some modules that need to be installed manually, like StarNet++ that can let you remove stars from an image, and then later on you'll be able to place them back in. It's very useful to process only nebulosity for quite a while until you put the stars back in. And you also have something called Deep SNR that can remove a lot of noise from your images. There's also some alternative called Graxpert, and we'll get to that in a moment as well. It's technically a module outside of PixInsight, but I'll show you how to install that as well, and it's free. I will recommend one piece of software, in particular one module called Blur Exterminator, that is not free. It is absolutely not mandatory, but it lets you achieve mind-blowing results by doing an operation called deconvolution on your images in a fully automated way. So it extracts as many details as possible from your image, and it's honestly a bit mind-boggling. So if you have $100 in addition to the €300 that you have used on the main purchase of PixInsight, I highly recommend buying Blur Exterminator. You can get it here. You see Blur Exterminator, AI-powered deconvolution, $100 US. You also have a free trial if you want to try it out, or you can purchase it. This RC Astro website, and again, I'll have the link in the description. You can also, and it's really good, you can download and buy Noise Exterminator, which is a plugin that lets you remove noise in your images. That is $60 US, and Star Exterminator that lets you remove stars. But both Noise Exterminator and Star Exterminator have equivalent that are free. So you don't really need to buy those, they're just very convenient to have. Anyway, let's go through all of those plugins one by one, and I will start by the plugins that can be installed very easily in PixInsight. So let's go in PixInsight again, and now I'm going to go to Resources, Updates, and Manage Repositories there. Let's go there. We have a list of stuff in here. And I've prepared a list of repositories that I'm going to be adding, and let's add them together. And most of those are free with the exception of those RC Astro plugins I just showed a moment earlier. So let's add them one by one. I'm going to copy paste this, and I'm going to click on add in PixInsight, paste the URL, and say OK. Okay, we've added one URL, and then we can do the same for all of the other URLs. This one is Blur Exterminator, so if you didn't buy Blur Exterminator, you don't need to add it. This one is Noise Exterminator, same thing. If you didn't buy Noise Exterminator, you do not need to add it. This one is Star Exterminator. If you do not have Star Exterminator, you do not need to add it. And then this one is something that lets Blur Exterminator, Noise Exterminator, and Star Exterminator run much faster if you have a compatible NVIDIA graphics card in your computer. So I'm going to add it because I do have that. The first one that we added, by the way, DB Extract, is very useful if you have one-shot color cameras and that you use with dual-band narrowband filters like the Optolong L Extreme. If you don't do that, if you do not do any narrowband imaging with your one-shot color cameras, you do not need this one, but it's excellent otherwise. And then I'm going to add a series of scripts, this one from a person called Frank from Seti Astro. He has his own YouTube channel. I'll put the link down below. It's absolutely amazing. He has incredible scripts that we'll be using pretty much all of the time. So that's what we just added. I'm going to add this. Actually, I'm going to add that later, this Graxpert process, because it does require something else. I'm going to add all of those Cosmic Photons scripts. All of those are free. Let's just add them, and you'll be using them for most of your images. So you can see I'm slowly adding all of my repositories. Most of these things are free. Okay, the last one, Image Blend, which I won't have in my flow, but it's good to have. Here we go. We've added a lot of repositories. I'm going to click on OK. And now I'm going to go to Resources, Updates, and check for updates. And that will, PixInsight will basically access all of the repositories that we just added and see what needs to be downloaded. So it's going to take a little bit of time. Here we go. And we see, okay, this is all the stuff that we need to download. So I'm just going to click on Apply, just like we did earlier for the initial installation of PixInsight. Okay, and here we are. Our updates, our modules have been installed. So just like last time, I'm going to click on OK, close PixInsight, say, yes, I do want to install the updates, and restart PixInsight. Okay, we are done with the installation of those modules, but there's still more initial setup work to do. Don't worry, everything that we've been doing up to now, you only need to do it once. So it's one-time pain for long-term gain. And that's the philosophy of being lazy. You're busy in the short term, lazy in the long term. That is my style. Okay, and the next thing that I'm going to install is StarNet, or StarNet++, which is the free way of removing stars. If you have bought Star Exterminator, this step is not needed. You can completely skip it. But for now, I'm just going to see that I downloaded a version of PixInsight that was 1.8.9-3, and probably so have you, or a higher version. And you can just download the fresh install of StarNet 2 Win. So let's just download this and wait until the download is over. While we're at downloading stuff, we're also going to download Deep SNR. Again, I'll have all of the links down below. So Deep SNR, this is the official page. We're going to click on download. And because we'll have installed StarNet first, I'm going to have download if you have StarNet installed, and I'll just download this package here. That should make us ready. So we've downloaded StarNet, and we've downloaded Deep SNR. And I'm going to download another tool that we'll be using from within PixInsight, but that also works as a standalone tool if you ever need it, which is called Graxpert. And yeah, all of this is incredibly free on top of those €300 that you do pay for PixInsight. So for me, I'm going to download the Windows version since we are using Windows, and we're going to go through the installation of all of those tools. First step will be for me to close PixInsight. make sure you have PixInsight closed. And then you want to have one window explorer opened to see program files, PixInsight, and then you select the bin folder in there. So we just have this folder open somewhere. I'm just going to iconize this and open another Explorer window. And using that other Explorer window, I'm going to go and look at my StarNet++ and at the deep SNR files that we have just downloaded. Here they are. I am going to unzip both of them so we can extract all StarNet in a folder, and I'll do the same thing for deep SNR. Extract all deep SNR into this folder. Let's start with the StarNet install. We see we have this folder. There is a helpful README that basically tells you that you want to close PixInsight, copy the files into the bin folder that we just prepared, and then run PixInsight before doing this operation. So let's do exactly that. I'm going to take those files, StarNet to pxm.dll. Actually, I'm just going to select everything. On my keyboard, I will do Control-C to copy. I can also just right-click and copy here. And then I can go to my other Explorer window that's in the bin folder of PixInsight and just Control-V for paste. And here it tells me that I already have a file named tensorflow.dll, and that is likely from my Blur Exterminator installation. I will not replace this file. I will skip it because I already have it in there. Then I need to provide administrator permission to copy to this folder. I'm just going to click on Continue, and we are done. We have added StarNet++ to some extent. Now I need to again follow the README and open up PixInsight. And once PixInsight is open, you can go to Process, Modules, Install Modules. Just click on Search, and you can see one additional PixInsight module was found. And I'm going to click on OK. You can see StarNet 2 has been selected. Now I just need to click on Install. And here we have our StarNet module is now installed. If I go to Process, etc., and I can see we have StarNet 2 here, so we are ready to go. Now I'm going to close PixInsight again for the next installation, which is Deep SNR. And I'm going to go to the folder that we just extracted. Click on here. Here we go. I can open up the README, and the README says something extremely similar. I'm just going to select those two files here, Control-C to copy those files, and then I go back to the bin folder of PixInsight, and I do Control-V on my keyboard to paste into the bin folder. There we go. Then I can open up PixInsight again. I can click on OK, and just like last time, I will go to Process, Modules, Install Modules. I'm going to click on Search. It found a new module. Deep SNR has been found. I can click on Install. It tells me it's installed. And if I go to Process, etc., here we have Deep SNR. So now Deep SNR is installed. We are really on our way of having properly set up PixInsight. We're not quite done. There's a few more steps, but we're getting closer. Okay, next we are going to install that standalone tool that has some hooks into PixInsight called GragSpert, and it's going to be used for noise reduction if we need it, and also for background extraction to smoothen the background of your images. It's very powerful like that. So I'm just going to double click and then just follow the instructions to install GragSpert. Click on Finish, and now we'll run GragSpert. Again, it looks like unrelated to PixInsight, but trust me, we'll make it related to PixInsight. So I'm running GragSpert for the first time now. And in GragSpert, I will click on the Advanced tab on the right here, and under Background Extraction AI Model, I will select 1.01. And under the Denoising AI Model, I will select either 2.00 or 3.02, either works. And then I'm going to close GragSpert. Now we should be okay with GragSpert installation, so I can launch PixInsight yet again, and we are going to add one last module, which is the GragSpert process. So it is this line there. Again, all of the links will be in the description. I'm going to copy that, and we're going to go to Resources, Updates, Manage Repositories, click on Add this URL, click on OK again, close PixInsight, click on Resources, go to Updates, click on Check for Updates, and you see it has detected the Graxpert process, so I'm going to click on Apply. And it will download the process. It's successful, and again, we will restart PixInsight while installing the updates. It's starting to be very familiar, right? Again, one-time thing. You don't have to do it again after we're done once. Okay, now remember those Gaia files that we downloaded while we were downloading the initial PixInsight package? We're going to set them up now. So for that you want to click on this Process Explorer icon on the left-hand side. Just double-click here on Gaia. This will open this window. And what you want to do is ignore everything, just click on that little wrench here at the bottom right, the preferences. And if you have downloaded the Gaia DR3 files, like if you were planning on using PixInsight offline without internet connectivity, you can go ahead and select the files. So for me, remember it was under this Gaia DR3 folder. I actually do not use those files, but you would just like select all of your files, click on Open, and that would add the Gaia DR3 files. To add the Gaia DR3/SP file, it's exactly the same process. I'm going to click on Select, and this time Gaia DR3/SP, I select all of the files, click on Open, I click on OK, and then I will click on this round icon here, and that should be enough. Now we have Gaia set up for any spectrophotometric color calibration that we want to do. With this, our installation is almost done. There's one more step for Blur Exterminator, and Star Exterminator and Noise Exterminator. If you have chosen to purchase or try them out and install them, you need to go into each of the processes, and to do so you click on Process Explorer, you search under All Processes for Blur Exterminator, and you double click on it to get this. In the bottom right you will click on the wrench, and you need to put in your email address and your license key that you have received from RC Astro while you purchased this. You need to do the same thing for Star Exterminator if you have purchased Star Exterminator, and also Noise Exterminator if you have purchased Noise Exterminator. And with that, that is officially the end of the initial setup of PixInsight. With that, you are all ready to apply the 20 to 30 minutes workflow that I use on all of my images, basically. Before that, I will show you the basics of the PixInsight interface and philosophy, how to open an image, what is a process, what is a script, and how to apply them onto your image. These will be just the basics of getting used to it. I will also get into some elements of the interface that are critical for us, called the screen transfer function, as well as the basics of what is an unstretched image, also known as a linear image, versus a stretched image, because those two are very different and you cannot apply the same processes on an unstretched/linear image compared to a stretched image. But we'll go into all of those details. By the way, as you can imagine, making this video is a huge amount of work, and I hope it's going to be useful for a lot of people. So I would really appreciate if you take a moment to click that like button on the video, leave a comment to let me know what you think of this. And it's really just liking and commenting actually helps the channel a lot already. If you want to help the channel even more, support my work here at no cost to you, and you're planning on buying any equipment from Amazon, Agena, High Point Scientific, etc. I mean, from Amazon it can be anything. You want to buy a computer, pants, whatever, from Amazon. If you do so, after you click on the links that I have down in the description, it will help me out at no cost to you. And if you want to help my work more directly, to become an actual sponsor of this channel, you can do so by joining my Patreon as a supporter. The link is down in the description. Or you can also join the channel as a member. This is the join button next to the subscribe button. Talking about the subscribe button, if you're new to the channel and you like this kind of tutorials, I also do a lot of equipment reviews, everything related to astrophotography. You may want to consider subscribing by clicking on that subscribe button and also turning on all notifications with the bell icon. Okay, with that, let's go to the interface part. Okay, so PixInsight has many tools that are available, and it does not hold your hand. In many other pieces of software, you'll have some kind of workflow that is part of the software, like an order at which you can do things. PixInsight is not like that. It gives you access to all of the tools. You can use them or use them to your heart's content. And those tools are divided between processes that you can have under the Process tab here, or as we've done the Process Explorer on the left here, where you can look at all processes, and you see a list of icons there. Each of them is a process. And you also have another thing called scripts that you can go under scripts, and they're usually organized as, like Seti Astro scripts, utilities scripts, that kind of stuff. You can also go into the Process Explorer, open up scripts here, and then go to all scripts to see all of the scripts that are installed. From a technical point of view, processes and scripts are different. That's why PixInsight separates them. But honestly, from an end user point of view, conceptually, they're the same thing. They're both tools, and it can be very puzzling to understand the difference between those two. In general, there are only practical differences in how you apply a process to an image versus a script to an image, and I'll show you some examples later on. The first script that you'll be using in PixInsight very likely is going to be the weighted batch pre-processing or the fast batch pre-processing. This is to do your initial image stacking in PixInsight. This section, I'm going to be very brief about it because this is a very deep topic, but I'll show you some settings that typically work well for most cases. At the same time, if you've been processing your images before with software like Cyril or Deep Sky Stacker, for instance, you probably already have a flow to stack your subframes into a final image. And you can keep using other software to do this stacking for now, and then just open the final image in PixInsight. That works perfectly fine. So I'm just going to show you how to do the stacking in PixInsight if you wish to do so. Otherwise, you can use the tools that you are used to. I do think the stacking in PixInsight works great, but then so does Deep Sky Stacker, for instance. So for that, I'm going to go into Script, Batch Processing, and we're going to use Weighted Batch Pre-Processing. I'm going to click on this, and it will, after a little bit of time, open up a window where you can select your light frames, dark frames, flat darks, bias frames, and flats, if you have all of those calibration frames. The minimum is light frames. Those are images of your targets. If you're not familiar with what calibration frames are, I have another video on the topic that I published on the channel recently. I'll put the link up above and down in the description if you're interested. It's really a prerequisite of stacking your images, so it's good to know exactly what those mean. Anyway, here is the process. What I normally do is I simply click on the plus lights at the bottom here, and I go to a folder that contains my light frames. Let's say for a target like M27, I can select everything and click on Open, and that will add light frames here. Then I can do the same for my flat frames. Click on plus flats, go to my flats, the flats that I have created with my telescope, add them. We can do the same for bias frames. I'm going to click on plus bias, and we're going to go in there, and I have a series of bias frames that I have prepared, and I'm just going to open them. And then if you have dark frames, I typically don't use dark frames with my cooled astrophotography cameras, but if you do have dark frames and dark flats, you can put both under the darks folder using the plus darks button there. By the way, when you are using this tool, the weighted batch pre-processing or the fast batch pre-processing in PixInsight to stack your images, if you have images from multiple filters, like a monochrome camera, in which case you have flat frames for each filter, and you also have light frames for each filter. You can also have that with a one-shot color camera if you're using an H-alpha oxygen 3 filter and then a sulfur 2 oxygen 3 filter, for instance. That's possible. You can actually just dump all of your light frames for all of your filters at once into the process. And you can do the same thing for the light frames. There is one condition to that. It is that in whatever imaging software that you are using, for instance, Nina, you have your filter wheel or even your manual filter drawer set up properly so that the imaging software, whether it's Nina or the Sii-OIII or Voyager or etc., but this imaging software should tag each of the file that it saves with the filter that the camera and the telescope was using at the time. That's critical, and once it's tagged properly with the filter, it's actually metadata within the file itself, and that means that when you dump all of those files for all of your filters at once into the weighted batch preprocessing tool, so for both flats and lights, PixInsight will look at that filter information and will be smart. It will group the frames per filter, it will group the flat frames per filter, and it will properly apply the correct flat frame to the correct light frames, etc., etc. It's pretty magical, but it does rely on making sure that your capture software does that initial work of tagging the files correctly. One advantage of doing all of the filters at once, by the way, in PixInsight is that you end up with an image for each filter and all of the images are already aligned to one another. There is nothing for you to do. You do not need to align them to one another manually. If you haven't tagged your light frames and flat frames with the relevant filters, then you will need to stack manually for each filter. And hopefully you have kept track of which files were for each filter. Once you're done, you can amend some of the parameters. I usually actually leave this local normalization off because it takes a lot of time and I haven't seen enough improvements for me to really see the point in using it. And usually the rest of the parameters can be kept as is. If you are seeing that when you run the process, it's going to take like 24 hours or something crazy, and you've been using a lot of light frames, it's possible that in integration parameters, you have this rejection algorithm here set to auto, and sometimes PixInsight will set it to generalized, extreme, studentized, deviate. That thing takes an incredible amount of time for very little value added. So if you ever see that the weighted batch preprocessing takes absolutely forever, just force it to use Windsorized Sigma clipping with the default options. That usually works very, very well, and so you don't need to bother with anything else. Otherwise, just keep it on auto. And you see, we basically didn't change any settings. It's just adding your frames, lights, flats, darks, bias. I uncheck local normalization, and if you have well-dithered data and you want to do some drizzling, and you can skip this if you have no idea what I'm talking about, but you can go under calibration, and under your lights you can click this setup here, and if you have a color camera and you are going to be doing drizzling, so if both of those conditions are true, I would recommend setting the De Beer method to bilinear, only if you're going to do drizzling, remember. Otherwise, keep it as default. And then you can go to post-calibration, and in here, select your light frames, click on Enable, set a scale of 2, a drop shrink of 0.9, 0.8 would work well as well, and a function that can be either square or var shape with beta equal 1.5. You don't need to understand what any of this does, just, use those settings and they should work pretty well. If you do not do dithering and drizzling, you can completely ignore those two steps under calibration and post-calibration. But with here, this kind of setting will work excellently with software such as Blur Exterminator, that process that costs $100 US. And it will let you effectively quadruple the resolution of your image. Then you can choose an output directory. So for me, I could select like this directory D process, whatever, and then you can click run. And this will give you a summary of what it's going to do and how much disk space it's going to use. And then you can click on continue and let the process run its course. This can take several hours. So yeah, go do something else. And it uses all of your computer power. So your computer is basically unusable while PixInsight is running through that. So yeah, leave it be. I'm going to click on cancel. And once the process is over, you can go to the folder where you did the stacking and you'll see something like this with even more folders, but the folder you'll be interested in is this master folder. And this master folder, you'll see the final frames of your image, and the interesting ones will be either this one, just autocrop.xisf at the end, which is if you have not done any drizzling, that's what you want to use. If you have done the drizzling, as I showed earlier, you will have this drizzle 2x autocrop XISF. And to open one of those images, you can just drag and drop it into PixInsight, onto the main screen of PixInsight. And you see I've dragged, dropped it, and now PixInsight opens it. Now, a lot of the images that are generated by PixInsight, they're actually multiple images contained in one image, which is why you get two images as windows in PixInsight. You see those two images. And they appear to be completely dark. That is absolutely normal because those images are basically exactly what your camera sensor registered. Your camera sensor, all it does is it counts photons. Technically speaking, it counts electrons that have been converted from photons, but whatever, let's say it counts photons. And so it just says like, hey, this pixel saw 10 photons. That pixel saw 20 photons. That's all it says. And our eyes in real life do something similar, except that our eyes, they will apply automatically like some contrast and brightness adjustment in your eyes, seriously. And that operation of applying like brightness and contrast adjustments is called stretching an image. Before you stretch an image, it's in a linear state, basically what the camera recorded as is. After you stretch your image, which is something we can do with PixInsight, the image is stretched. And so the linear stage is basically the raw, pure image, physical representation of what was captured. Post-stretching, it is the stretched image that has been processed in the same way that our eyes do real-time processing of the images that reach us. And it is no longer a pure representation of the signal that was captured. It has been modified. The brightness has been adjusted, the contrast has been adjusted, tons of stuff has been adjusted. It is no longer pure. And in PixInsight, there are some processes that should be used in the linear stage and other processes that should be used after you have stretched the image. But don't worry, we'll go into the workflows to see exactly when you can use those processes. Anyway, I was saying we had two images, but as we said, they're in linear stage, and so they appear dark. You see some stars, you see maybe the core of very bright objects. This is the nebula N27. How do you have a better look on the image? Well, if you've installed PixInsight, you will see those icons on the top right. Let's try to click on this icon. It's called STF Auto Stretch. I'm going to click on it, and suddenly we see something better. Now we can see what we're looking at. To note, this has not made any actual changes to the image. This is display only. It's just for us to see what we're doing. The image in the background is still linear. We haven't applied anything to the image. This is something very important to understand about this operation. If when you click on this STF icon, you get a completely green or blue or red image, and you don't see anything, what you want to do is, instead of clicking, you can hold the control button on your keyboard and then click that button. This is the difference between a linked stretch and an unlinked stretch. So this function does a virtual stretching of the image. It doesn't apply to the image. It's just for display purposes. It can do it exactly the same way for the red, green, and blue colors that are in the image, or it can do it separately. It will look at the red portion of the image, apply a stretch. It will look at the blue portion of the image, apply a stretch. It will look at the green portion of the image and apply a stretch. That's unlinked. Unlinked is control click. Linked is shift click on this. And you can see when I use the linked thing, I get a lot of green all over the place. It's not really nice. I can control click instead to do unlinked and see what I'm doing far, far better. So that's one of the images. What was the other image that got put on me? It's actually just to tell us what was cropped by PixInsight during the stacking. You can safely close this. So here we have one image that is available, and we can do this screen transfer function, what is called a screen transfer function. It just affects the display. It does not do anything to the actual image. If you want to look again at how the image looked like in a linear state, you can just click on that little button here with an X, and now we're back to where we started. But all of those operations, they just affect the display, not the image itself. Okay, so what about processes on this image? How do we apply a process to the image? Well, you first open the process. So let's say I want to apply Blur Exterminator. So I go to my process list under All Processes, and I double-click Blur Exterminator. And let's say I want to use the default settings. And you can see this is the process window. This is the image window. So there's multiple ways to apply a process. You have an arrow here, or a little triangle. We have a square here, and then we have a real-time preview icon here. Not all processes have this available. You can see I opened another process called LRGB combination, and here we have also a little round thing, which is apply global. The differences between the triangle, the square, and the round thing are very subtle and difficult to understand, and even after years of using PixInsight, sometimes I don't know what to use. The short of it is that if you want to apply a process to the image, you can click and hold on the triangle, drag the triangle onto the image that you want to apply the process on. And by doing so, you can see I took the triangle, clicked and dragged it to the image. Now we're applying it to the image. When you're applying a process, the dark window on the left, the console, will actually open up to tell you the progress on applying that particular process to the image. Right now, I am applying Blur Exterminator to this image. And now we are done with that process. So I've just applied a process to the image. Now I can also use an undo, the arrows at the top left. I can undo and redo to see exactly what happened with that process. Undo and redo. Undo and redo. So that's what this process has done for my image. There's another way to apply a process. So I'm going to undo this, and instead I'm going to click the square button. The square button is just saying apply this process to the last image that you have selected. So if I select this, then select this, and click on the square icon, it will apply the process to here. And here we go. So we've used the square icon to apply the process. So I can undo again, and I mentioned the preview icon here, this circle. If I click on it, and depending on the tool, it will take longer or less long, it will show you a preview of what you can expect to achieve with that process once you've applied it to the image. So I'm just going to close this. This is something that I actually don't use that often, except in curves transformation. We'll go to that in the full flow that I have for my images. Okay, and I mentioned the last one was this apply global. Apply global is usually available on processes that create a new image. For instance, this process can take as input multiple other images that are open on my PixInsight workspace and create a new image. And to create a new image, I'll be clicking on this apply global, so we have a new, completely new image that is created. I could also apply to target so that the new image overwrites an existing image, specifically the last one that we had selected. So that's where it gets a bit confusing. If you're ever confused about what's happening, just use one of the methods, and if it doesn't work, try another. Sometimes you just have to stumble about in PixInsight. But you'll see when we'll go through the flow, I'll use the correct icon so you see exactly what to use and when. There's another trick to applying processes. You saw with Blur Exterminator that sometimes a process takes a long time to be applied and computed to an image. So instead of applying a process to the whole image, you can apply the process to part of the image. So you see what it would look like before you spend the time investment of applying the process to the whole image. For that, at the top of the screen, you have this little icon here, which is creating a new preview. Just click on it, and then you can drag and drop to create a little square on the image. And you can click on the preview here. So you see you have the main image as a tab here, and you can go to the preview here, and now we can drag and drop the triangle just to the preview to see what happened with our image. And this time it's much faster. If you want to see the before after of a preview, you do not use the undo and do buttons because those apply to the overall image. You use this little button there that is specific to previews. So undo, redo, undo, redo, just for the preview. And once you know that those are the good settings that you have for your process, you can go back to your main image and go ahead and apply the process to the main image. There's some other things that you can do with your main image. You can see the name of that main image is super long. It's too complicated for me, so I can go to this little tab here and double click. And now I can rename it, and I could say like I want to rename it to M27, and here we go. Now we have M27 and we have the preview. If you ever want to remove the previews because they are like kind of disturbing you, they're ugly on the image, you can go to preview, delete all, and now we've removed all of the previews. You can also zoom in and out of your image using the scroll wheel. So I'm using the scroll wheel to zoom in. You can then move around the image by moving those bars here. Or you can also hold space and then drag and drop on the image to move like that by holding the space bar. You can also do some other things with the image. You can iconize it. And once it's iconized, you can move it around and you can double click on it to reopen it. You can also grab the tab at the left, drag and drop it somewhere else, and that will create a clone of your image. That can be useful from time to time. You can also choose to get a gray version of the image. That can be useful from time to time, and I might show you in the flows where you select an image and then you click on this icon here that will let you extract the gray component of the image. Let's apply the screen transfer function to the image. That's what we get. We could also decompose the image into red, green, and blue channel using this little button here on the top left, red, green, and blue channels. And again, we can see, oh, this is the blue. Oh, this is the green. Oh, this is the red. And that's a lot of tools that can be useful for us. And I can just close the images, clone them, etc. If you ever want to compare two images, by the way, let's say I have this image of M27 that has blur exterminator applied, and I have that image that doesn't, and I want to see on the zoom-in version of the image how it looks like, I can have both images side by side like that, and if I want to match the field of views between the image, I can take this little tab, drag it onto the tab of the other image, and boom, we now have the same field of view and we can compare side by side. That kind of trick is available. There are lots of tricks available. You don't need to remember all at once. It's just very useful and very powerful. Then there's another very powerful thing with PixInsight is if you're using a process with specific parameters all of the time, you can drag and drop the arrow directly onto the workspace rather than an image. That will create an icon that you can then use by double-clicking on it and then applying to the image. Or you can just grab the process and drop it on the image to apply it there directly. And what's cool with that is that you can create so many process icons. You can then right-click anywhere on the workspace, go to process icons, and then you can save your process icons and then load them later on. For me, I actually have my set of process icons that I like to use. And poop, there you go. Those are all of the stuff that I use often. And you can do that with your processes. Now let's talk quickly about scripts. Scripts are run very similarly from processes, except that usually the little triangle icon does not work. So let me open a script randomly. For instance, Seti Astro Automatic DBE here. I'm going to open the script. And here, what will happen is this triangle will not work. If I try to do something, it will give me an error. I can set the parameters of my script, and once I'm ready, I will just click on execute. And different scripts have different names for how to execute to the image, but we'll basically apply the script to the latest image that you have selected. So it works, scripts basically only have the square icon available to them, except that it's not square anymore, it's something else. So that can be confusing, but again, this is something you'll get used to very, very quickly with PixInsight. Let's execute, and now the script is being executed on that particular image. And now we can look at the result of that script, which was actually to smooth the background out. And those are basically the basics of scripts and processes and window management and image management in PixInsight. It's a lot to absorb, but don't worry. We'll go step by step through an actual workflow processing the Pleiades. So let's get there. Okay, so now that all of the groundwork is in place, it is time to do our first scenario, which is basically a one-shot color image with a color camera. The image is already stacked, so I'm going to open it in PixInsight. I have it here, so I can drag the file into the main PixInsight interface, and it will open up that image. And just like I told you before, we have like some multiple images contained within. The real one is this one here. And I'm going to do Control-click on the screen transfer function so that we see what we're talking about. And we can also see two other images, and those are called rejection files. They are basically showing you what the stacking process rejected as being wrong. And we can mostly ignore them, except that there's one thing that is very convenient to have. If you end up with a stack that has this rejection low thing, you can use it as a guide for cropping. But I'll show you many ways we can do that. So first, let me talk about a type of tool that is actually called dynamic tools. And I haven't talked about that yet, but we'll go to the Process Explorer. I'm going to go to All Processes, and I'm going to find Dynamic Crop. Dynamic tools, they're basically applied to a specific image, and as long as that image is under the control of a dynamic tool, it cannot be closed. And it's a tool whose parameters and let's say behavior within the image can be changed dynamically, thus the name Dynamic Crop. You can see Dynamic Crop has the triangle, but also has this check mark for execute and cancel. And let's see how it can work. For example, I can look at the Pleiades there, and I see there are stacking artifacts on the left edge, on the top edge. And so I can click and drag while holding my mouse button. And you can see I can set the new field of view that I want to have for this image that cuts off the stacking artifacts. And I can move it around like this by clicking and dragging as is. Once I'm done, if I try to apply it like this, it's not going to work. It's like, no, your image is being used by a dynamic interface. You cannot do that. Well, yes, that's the dynamic interface that we're trying to apply to the image. Okay, that's fine. We can just click on the green arrow and we're done. We've done the crop, and then I can close the tool. Let's go back one step before the crop to show you another way we can use dynamic crop, and that's actually very useful, and we'll use that in when we use LRGB images from a monochrome camera. But you can use, for instance, an image like this one where we see the white bars are very indicative of the artifacts, the stacking artifacts that we have. So I can apply dynamic crop to this image, say like, okay, this is going to be the cropping ratio that we want, except that we're not applying it to this image. Now I'm going to drag the triangle to my main image. And it's basically going to apply the crop that I have defined here to my main image. And this time it will work because my main image is not under the influence of any of those dynamic processes. So let's just apply it. Here we go. And you can see now we have cropped, and we've followed exactly the definition of this crop. While I'm at it, let me show you what happens if I try to close this image. It tells me, nope, you cannot close a dynamic target because we don't like it. So I can just click that X button to cancel and close the image. And I also don't need that image. Okay, so our first step has been to crop the image so that we remove any stacking artifacts, or you just get to the field of view that you like. Then we can, I will do something else. This image was taken by a hyperstar type of telescope. It's a bit like RASA telescopes. And there's something that is with those telescopes is that they tend to mirror the image. And normally you don't need to do that, but for me I will need to do a mirror operation on this image. I can simply go to Image here, Geometry, and then Horizontal Mirror, for instance. And that gives us the orientation of the image that is typical for images of the Pleiades nebula, so you can compare yourself to others more easily. This step, it's just specific to my setup. You do not need to follow it. We then can go to the next step, which is called background extraction. And we have multiple choices on how to do that. The background extraction, basically, you see how this corner is kind of greenish. This one is like green, yellowish and bright, and this corner here is dark. There's definitely some gradient going on in the image, and that gradient is hiding a lot of the nebulosity. So we are going to take care of that. Simply, I'm going to use a tool, a script called Automatic Dynamic Background Extraction, or AutoDBE. So for that, you're going to go to Script, Seti Astro, and search for Automatic DBE. I'm going to turn that on, and we get the script information. And I'm going to keep the default settings. I have a longer video about this script if you're interested in learning more about it, on how to change the parameters, but usually the default parameters work quite well. So I'm just going to click on Execute and see what happens. The script has created two new images. The extracted background, I can do a control-click via STF to see the type of background that was extracted, which looks pretty good. And then an image with the background extracted. This one here is the original image. This one is the one with the background extracted. Let's do a control-click on the STF. And now look at the massive difference we see in terms of the details that we can see in the nebulosity. They're no longer hidden by the background. That's excellent. We can try another method of doing the background extraction. It's good to have both tools in our shed, which is we're going to use Grexpert. So in Grexpert, you can open up the process, and we're going to choose background extraction here. And by default, the smoothing is likely going to be at 0. Zero smoothing can have its issues, so I really recommend setting it to 1 and also having the show background checkbox turned on. And I am going to apply that to our image, and then we'll be able to compare the result of Grexpert, which is, as you can see, fully automated, and AutoDBE, that is also fully automated. AutoDBE is more of a very statistical approach to background extraction. Grexpert is using AI to do this background extraction. Now we can see the result with Grexpert. I'm going to close the tool, and we also can see the Grexpert background that has been computed. And honestly, I think both images have done a great job at background extraction. And I don't know which one we should use to keep going. You can choose whichever you prefer. Maybe I'll simply go with the Grexpert image. So I'm going to iconize the old image, set it aside. The initial image, I'll do the same, set it aside. And now we're going to keep processing on the Grexpert image. So here we have our image, and you've noticed that up to now, whenever I did the screen transfer function, I did a control click to do this unlinked stretch, where we stretch the red, green, and blue channels independently. Let's see what happens when I do a normal linked stretch using the Shift plus click button. You can see the colors are kind of weird. It's greenish, and we know that this particular nebula is actually blue. So what we'll do, and that's something that you typically want to do with pretty much all of your broadband color images, or if it's with a monochrome camera, after you've merged all of the filters together into a color image, we're going to use a tool called spectrophotometric color calibration. So I'm going to go to my Process Explorer, and as usual, under All Processes, I will go and search for spectrophotometric color calibration. Here we are. In there, you can typically keep the default settings. There is one thing we can do to make the process slightly better, is to create a preview and select a region of interest. So the game here is to find an area of the image by zooming in, for instance, where you have a lot of background and very few stars. Like this is a good representation here of the background. Remember how to create a preview on your image? We can click on this button here, and then I can drag and drop to create a preview. I'm actually seeing that this area here might be even better. So I'm going to click, drag, and drop. And now we have our preview here. From there, I can go back to my spectrophotometric color calibration tool. I'm going to check region of interest. I'm going to click on From Preview. And then in there, I can select, oh, there it is, the preview that we have just created. Here we go. I'm going to validate this preview. And we can leave everything else the same. Actually, to be honest, we didn't even need that region of interest, but it's not painful to put in. And now we are also going to notice that you have the catalog here set to Gaia DR3/SP. This is actually the 4 files that we downloaded together and then we set up earlier in this video using the Gaia process here. So if you haven't done that before, make sure to go back in the video to set up that Gaia process with the files. Otherwise, it's not going to work. So now we're going to take the little triangle there and drag and drop it to the image to apply that process onto the image. Aha! We get an error. The image has no valid astrometric solution. So that happens to images that typically have been stacked with older versions of PixInsight. Recent versions of PixInsight, like the one you are using, normally you will not get this error if you have used an output to the script that is called autocrop, where you do not need to do further cropping and the image is already solved for you, meaning that PixInsight knows exactly where in the sky the image, the target of the image is. So to fix that and to be able to use the spectrophotometric color calibration, we first need to have PixInsight look at the stars in this image and say like, oh, yes, looking at those stars here, I can say that this is the location of the image. So it's the Pleiades. So for that, I can go to Script, Image Analysis, and ImageSolver. Here we go. In here, we have a lot of parameters. And in those parameters, we have in particular the information about the target. And for that, the easiest is to click on Search. And in there, I can search for the Pleiades. And then click on Search. This actually uses an online catalog. So if you do not have online connectivity, you'll need to find those coordinates by yourself. Now let's see, M45, that's the one, and you can see that the coordinates there, RA and declination, they're the same as the one that were already pre-filled, or almost the same. And this is because the pre-filled ones actually come from the metadata that was in the image files recorded by your capture software, if the capture software had that information. So it might actually be already pre-filled for you and you may not have to do anything about it. Anyway, for me, I'm just going to click on OK. That doesn't really hurt. And then there's another parameter that is extremely important, which is the image scale. And so for that, you just need to set your focal length and your pixel size. For me, I was using the IMX533 sensor. The pixel size for that is in the camera specifications. It's 3.76 micrometers. And I was using a Hyperstar C6, and the focal length for that is 300 millimeters. So I can put that in. That said, if you have drizzled your data, you've done 2 times drizzled, as I showed how to do earlier in this video, you will need to do one of 2 things. Either you increase the focal distance to double it, to 600 in my case, or you divide the pixel size by 2 to roughly 1.9 in this case. This data that I have here is not drizzled, so I do not have to do that. But if it is drizzled for you, you will need to make those changes. By the way, in the model parameters that PixInsight will be using to determine where this image is located in the sky, you can choose to use your local DR3 files. Remember those files? Many of them that I said like were optional unless you were going to use PixInsight without any network connectivity, and that if you have downloaded them, you've also set up in the Gaia tool as well. Well, that's where you could use them. For me, I will keep automatic catalog and just press on OK. What will happen now is that PixInsight will actually consult an online catalog based on the coordinates that you set up in the script, and also based on the focal length and the pixel size. And you can see it's done basically. We have no error message. It has found the information that we needed, and now the image is solved. Finally, now that the image is solved, PixInsight knows which star is where, and therefore it can do the spectrophotometric color calibration. So let's try again. Click and drag the little triangle icon onto the image, release, and we're going to wait for it to do its work. Aha, there we go. We're starting to see a result. Now, when you see a lot of green points that are all along the lines on both graphs, it means that it worked very well. And this is what we have right now, which is perfect. So I can close this. And now we're going to do a shift click again on the image because we want to do a linked stretch. Now our colors should be perfect. I'm going to do shift click, and there we go. Doesn't this look absolutely gorgeous? I love this. I took this from Tokyo, one of the most light-polluted cities on Earth. Okay, so now we are ready to go to the next step. So if you have bought and downloaded Blur Exterminator, now is a good time to use it. So I can go to all of my process and search for Blur Exterminator, and then I can apply it to the image. Typically, with the default settings, it works really well. And note how I'm basically using those tools and those processes, and you will see that as we do processing on other images, I will keep using the same tools. So if you're doing that together with me, one of the things you could do is just take the triangle, grab it, and put it on the workspace. Just like I explained earlier in the video, this creates a process that you can then right-click on and then set icon identifier here and say this is BXT for Blur Exterminator. Click on OK, and then you can also save your process icons and reload them later on to reuse, so that you have all of your frequently used processes available at your fingertips at all time, rather than having to go back to the Process Explorer each and every time. Now that I have this, I could actually drag and drop this onto the image, and that would be exactly the same as dragging the triangle here onto the image. Let me release, and now Blur Exterminator will be applied. If you don't have Blur Exterminator, not a big deal. You can just skip this step. Everything else will be the same. Okay, now we can see the before and after Blur Exterminator. You see that it did indeed work its magic on the details of the image. Beautiful. My next step would be to do some noise reduction. And if you have a drizzled image, so you have an image drizzled by a factor of 2, before doing that, now would be a good time to basically change the resolution of the image to shrink it back to the original resolution of your camera sensor. And that will help actually with noise and signal to noise ratio. If you want to do that, we don't need for this image because it is not drizzled, but you'd go to Process Explorer, go to Integer Resample, here it is, and with the default settings, you could just apply this by drag and dropping the triangle to the image. And that would, I'm going to validate here, that would, resize it down. I'm going to go back because I don't need to do that for this image, but this is a step that you would want to do before anything else. Now for this particular image, because it's an image that was not drizzled, The best way to do noise reduction on it would be to use either Graxpert Noise Reduction or, if you've bought it, Noise Exterminator. If you had an image that was drizzled and then you resampled it down, you could also try Deep SNR using the Deep SNR process. For this particular image, Deep SNR will not work really well, so I'm not going to use it. Instead, I'll show you Graxpert, for instance, because Graxpert is free, so I know you have it. And we're going to select in Graxpert denoising, and I see that a method, a strength that works for me very well pretty much all of the time is roughly 0.75 or 0.8. So I suggest you use that as a starting point. And you could even create a preview. Remember that preview button here that I can click and then drag and drop on the image. Then we can look at the preview, and then I could apply Graxpert on the preview to see how well it works before, and then adjust the parameters before we apply to the final image. For me, I know that this works well, so I will simply click, hold, drag, go to the image, drop onto the image, and this will apply Graxpert. If it is the first time that you apply this Graxpert denoising onto the image, you will likely get a message telling you like, hey, I'm downloading the AI model, don't touch anything. It will take 5 minutes, 10 minutes, let it do its thing, and everything will work very well. Okay, and the process is done. Before we look at the result, I want to give some information as well. If you do not have an NVIDIA GPU, using the latest AI model here will actually be very, very slow. It's actually quite slow even with an NVIDIA GPU. If the Graxpert process takes too long, just switch to 2.0.0 and that will actually make things much faster. The result is also very comparable. So just keep that in mind if you see that it takes too long. The result looks like this. So just as reference, this is the kind of noise we saw at the center of the image. And now with this, oh wow, it is much, much smoother. That worked really, really well. Beautiful result. I'm wondering if this is actually not better than Noise Exterminator. Anyway, this is beyond our topic. The next step will be to stretch the image. Remember about linear image versus stretched image. Well, right now we're still linear. If I click this little X button there, pop, we don't see anything anymore except the stars. So what we can do is do the stretching of the image from a linear format into the stretch format. So this is a one-way street. And the easiest way to do that is simply to go to Script, Seti Astro again, and we'll go to Statistical Stretch. So let's click on that. And the default settings usually work really well. I can click on Preview Refresh here to see how it will look like once we apply to the image. If it looks like you're blowing out some of the brightest part of the image, then you may want to reduce this particular slider. For instance, 0.2 can work very well a lot of the time, and we can see the difference that would give us on the preview. You can see how much more contrasty suddenly it is because it stretched a bit less. So for me, I actually kind of like probably a result in between the two. I'm going to go to 0.22 and see what we get. Perfect. This looks good. By the way, if for any reason your spectrophotometric color calibration didn't work well, you can actually kind of rescue that by unchecking linked stretch here and then running it on your image. But for my image, I do not want to do that. Okay, so we have everything ready. I just need to click on the execute button here to do this stretching on the image. And you can see the operation is very fast. We're done. Now if I click on this, nothing happens because the image has been stretched, and oh my word, is it beautiful. Okay, now that our image is stretched, one thing that I want to do typically almost immediately after doing the stretch is to remove the stars from the image, and we can place them back later on. If you have purchased Star Exterminator, this is what you'll want to use. Otherwise, we've installed StarNet++ earlier, and because I'm sure you have that, that's what I'm going to be using. Under StarNet++, you will need to make sure that you have this Create Star Mask option checked. In Star Exterminator, if this is what you are using, you'll need to make sure that you have Generate Star Image and also Unscreen Stars. But for now, we'll go with StarNet, and I'm just going to drag and drop onto the image, and StarNet will temporarily remove the stars from the image and also create a new image with just the stars. There you see, that's the image with just the stars. So I can move that image somewhere, just iconize it and put it there. We're not going to use it for the time being. Okay, the next step would be if I see that I have some areas of my target that are super bright, and I'm pretty sure there are some details that are hidden in that super bright area, we could make use of a tool called HDR Multiscale Transform. So we can look into the process, go to HDR Multiscale Transform, and in there, I would suggest that you check to intensity, lightness mask, and you try to apply it to the image to see what happens. For this image, it's absolutely not necessary, but you can see what the impact is. This is before and after. It reduces all of that brightness to reveal the details that might be hidden in those super bright areas. This is far too strong. If you see it's far too strong for your image, you can increase this number of layers parameter to 7 or 8. Let's try with 8 and see what that would give us on our image. And you can see this is a much more subtle effect, even though it is still too much for me. I prefer to have the image with that like haziness to it. So we're not going to use HDR Multiscale Transform for this image, but it is something to keep in mind as is available. Okay, my next step will be curves transformation, and this is probably the most difficult part of PixInsight, or at least of this process in PixInsight, because it requires judgment calls. So to access curves transformation, we'll go to Process Explorer, double click on curves transformation, and in here we need to make sure that we have RGBK selected. That will apply to the whole image. And let me explain exactly what all of this means. Basically, you have an x-axis that has this little brightness thing. It goes from dark to white. And you have a y-axis that also goes from dark to white. I can look at this line here in the middle, and if I click anywhere on that line, I will add a point to it. You can see I added a point by left-clicking. I can remove a point by right-clicking. And we can also open a preview of how it would look like once I apply the curve using this little preview, real-time preview button that we talked about earlier. By the way, if when you open a preview, it's not on the right image because you have multiple images open, you can reselect which image you want the preview to be on. Anyway, to show you what's going to happen, I could select a point here. And then this is saying that pixels with this kind of relative brightness, so relatively bright pixels, if I drag this point up, I will say those relatively bright pixels should be brighter. And look at that, everything becomes brighter. And if I were to say like, oh, and I want the pixels that are relatively dark on the left-hand side to be darker, I would drag this down. And what you're seeing here is an S-curve. It's a typical contrast curve that makes bright pixels or bright areas of the image brighter and dark areas of the image darker. So you can see before and after. We can see it by clicking on the preview button, before and after, before and after. This is a very striking change. And I kind of like it, but I think we're going too far on the bright areas. So I'm going to reduce that point here. And maybe we want to also increase the mid-tones, like the medium bright pixels. Something like that. And let's see. We can play here and also say the dark pixels should be even darker, like that. You can see how we're moving the curve around to change it to taste effectively. And that's what's so difficult with this, is that it is to taste. So with this curve, I'm saying brighten the bright pixels a little bit, brighten the mid-bright pixels a little bit, darken the somewhat dark pixels a little bit, and darken the dark pixels even more. That's what we're saying with those 4 points on this curve. Once we're ready and we like our preview, we can close the preview and then use the triangle, drag it and drop it onto the image to apply our curves transformation. That image looks beautiful already. There's something else though that I don't like that much about this image, which is the fact that the background has a lot of almost a greenish tint to it. And if you have a weird greenish tint in the background, or if you have other colors in the background, we can remedy that. First, let's talk about the greenish tint. Typically, for deep space photos that are broadband in particular, you don't really have a lot of green color. So there is a tool in PixInsight called SCNR, so we can go to it here, and I'm going to double click on it, that can remove the green from your image. You can choose a certain amount of green that you want to remove, but it works pretty well with just the default settings. I can try to apply it to our image here using, as usual, the triangle icon, drag and drop. And wow, that makes a big difference. Look at the before and after. That greenish tint is completely gone. This is exactly what we want to do. This is great. There's still some kind of like a reddish, yellowish tint in the background that we could try to play with a little bit. And that's what we're going to do. We're going to play with the saturation of the image, and we can decide that we want to saturate the bright areas more than the dark areas using something called a mask. So to use a mask, what I can do is I have my image selected, and remember that little thing here in the top left that creates a grayscale version of your image? Well, I'm going to click that, and that will create, as I mentioned, a grayscale version of the image. We can use that grayscale version of the image as a mask onto the main image, and I explain exactly what that means. To do that, I can click on the little tab on the left, hold, drag, and then drop it under that tab here, under here, onto the bar to the left of the main image. And here, what is happening is that if I try to apply a process to the image, whether it's curves or another process, it will be applied only to the areas that are not red. So everything that is red is basically protected. We're not going to apply the process to those red areas. Everything that is less red is actually going to have the process applied to them. So that is the principle of a mask. This color red though is very disturbing. So what we can do is go to mask, and then we're going to click on show mask to stop showing the mask. But even though we don't see the mask anymore, you can see that the tab here is brown. That tells us there is a mask that is applied. As long as the mask is applied, by the way, you should not close that image. You can iconize it, but if you close it, the mask will be lost. So now that we have a mask, and that mask is basically saying like, yeah, processes will be applied to the bright parts of the image, I can go into Process Explorer. Again, I'm going to open Curves Transformation, and in Curves Transformation now I want to make sure that I go to this S sign, which means saturation. And in saturation, I'm going to open up a preview, and you can see the preview actually acted upon my black and white image. That's not what I want. I'm going to use the drop down here to go back to my main image. This is where I want to see the preview. And what I can do with saturation and just increase the curve, like make the curve like that with a single point, and you can see the before and after of the preview. We're really saturating the blue core of the nebula, and I really like that. So we can apply it once, and we could even try to apply it by drag and drop it the triangle twice. Now that is a very powerful blue. I really like that. Okay, but we've increased the saturation of the core of the nebula. I was saying that you can also kind of deal with the colors in the background of the nebula. Well, yes, you can. Simply by going again, after you've selected your main image, you go to Mask, and then you click on Invert Mask. And now if I go to show mask, you see that the red areas, meaning the protected areas that will not be affected by a process, are now the bright areas of the image. So we've inverted the mask. I'm going to stop showing the mask. And now I'm going to apply some saturation again. I'm going to open a preview, but we want to desaturate the background a little bit. So instead of having the curve to the left like that, I'm going to have the curve to the right. And see how on the preview this desaturates the image a lot. And this is before and after, and I think this is actually a pretty good compromise. Maybe even something like that. I can close my preview, apply this to the image by dragging and dropping the triangle, as usual, and now we have something that I really like. Okay, so now I think I'm done with my image. I just want to place back the stars into the image. So what I can do is I want to remove the mask because the mask is still applied here. So I'm going to go to Mask and Remove Mask. There we go. The mask is no longer applied. Now I want to add back the stars. If you've used StarNest, like I have, you will go to Process Explorer, and then we're going to use a much dreaded tool called Pixel Math, but there is no need to panic about Pixel Math. You just double click on it as usual, and we're going to click on Expression Editor here. And in there, we have Graxpert Denoising, that is my main image, and then we have Star Mask, that is my star image. So I can double click here on Graxpert Denoising, and then I say plus, and now we double click on Star Mask. And I can say, okay. Now that has created a formula for my image, and I can now open up destination here, and I will say that I want to create a new image, and everything will be the same as target. So I'll make sure to have this image selected first. Then in the process, I can click on the square button. This says apply to target. But because I'm saying it's going to create a new image, it's just going to use this image as reference and then add the stars and create a new image. Let me show you. Click on the square button, and there we go. We have a new image with the stars placed back, and how awesome does this look? I love astrophotography. Anyway, that is if you are using StarNet. If you are using Star Exterminator and you checked the unscreened star checkbox, then you need to do something else, another formula. So I'm just going to show you how it would look like. I'm not going to apply it because I did not use Star Exterminator, but you would go again to the expression editor. I'm going to empty everything, and you would do tilde, then open parenthesis, and then you will have a second parenthesis, another tilde, and you will put your main image, close parenthesis, we're going to multiply, and again open brackets, close brackets, and inside there we're going to add the star mask, and in front of star mask we'll have a tilde, and then we close the main brackets. So basically it is this formula just replaced with your main image on the left and your star image on the right. And I'm going to click OK. I'm going to quickly show you how that would look like. I'm going to click on the main image, click on this, and that's how it would look like for me. But again, this is not the right method for StarNet++, as far as I know. Yeah, you can see the stars look a bit transparent. It's kind of weird. So I'm going to close this, but this is the method that you can use if you've used Star Exterminator. Okay, I'm iconizing all of the images that I don't need, and now I have my image with the stars, and we could call this our final image, but it doesn't have to be. Maybe in a lot of images you have too many stars, they distract from the nebulosity, and you would want to decrease the amount of decrease the impact of the stars on your image. And there is a way to do that with yet another script. So for that, you can go to Script, Utilities, and in there you will search for Star Reduction. I'm going to open this star reduction tool, and in here you want to say that your target view is this one. For me it's image 26 here, and then your starless view, it's actually, it pre-selected them automatically. I don't know how it did that, but it did. You want to choose your target view and your starless view, and then you can change parameters, like you have basically strong, moderate, soft, and you can see a little preview here on the left. I'm going to keep it as strong, and once you're ready you can just click on apply star reduction, and that will create a new image with the reduced stars. So here is the new image, and you can see I love this end result. This is absolutely magnificent, and it was taken from Tokyo. This is our end result. We have successfully processed a PixInsight image together through the whole flow. Now we can save the image, so I would recommend save as, and you could save, I would recommend highly to save as an XISF file, so that this will save the full image with all of its details. You can also save it as a fit file if you want to, and that's useful if you want to share with other people that do not have PixInsight. And you can also, so let's do it actually. I'm going to save as an XISF file. You can just keep everything by default and click on OK. We can then again save as, and let's say I want to share with someone else, I can save as a fit file. And again, we're going to keep everything the same. I'm just going to click OK, OK, OK. I don't care. And then if I want to share on like Instagram, Facebook, etc., I need to save a JPEG file. So we're going to select JPEG and click on save. I'm going to say OK, and we can choose the quality. 80% is usually pretty good, but you could go like 90. Anything above 90 is like almost meaningless. But we can say OK, and we have saved our image. And that's it for our very first image that we processed. The next one that I'm going to do is going to be another one-shot color image, but this time with narrowband filters, an H-alpha oxygen 3 filter that I will process on its own first, and then I'll show you how to combine, if we have a one-shot color camera, with an H-alpha oxygen 3 filter and a sulfur 2 oxygen 3 filter. Because we've gone through the basics already in this initial process, I will be going a bit faster with this upcoming process. So make sure that you have reviewed everything on the Pleiades Nebula before you keep going. Okay, the next image that we are going to process is going to be a dual band narrowband image that was taken again with a one-shot color camera. Actually, this is the exact setup that I have next to me that was used to take this image. And it will give you an idea of how to process an image that you took with one of those very popular dual band hydrogen alpha / oxygen 3 filters, or even like quad band filters or dual band filters that, as long as they include those band passes, they can be used with the same purpose. So let's look at the image that I have. So this is the result of the stack, and I have an auto-cropped version of the image. So I'm just going to drag and drop that into PixInsight so that we open up the image. And again, we can see that this image actually contained two images. One of them is about like, okay, what is the crop that was applied to my image? That's fine. We can close it. And now I'm going to do Control and click on the screen transfer function, as always, so that we can see exactly what's happening, because the image is still in a linear state. Now to note, this image was actually drizzled, which means that it has a resolution, I think, of over 100 megapixels right now. But don't worry, we're going to resample that down later on because it's a bit too heavy to use. And it's an image of the North American Nebula. This is 110 exposures of 5 minutes each on that target that I took actually a few nights ago, again with this equipment right here. So how do we process this? It is pretty much the same thing as before with just a couple more added steps. So we're in the linear stage. We are on Rails. First, we need to extract the background. We have two choices to do that. Either the script Seti Astro Automatic DBE, or we could use the process under all process, Graxpert, and then set background extraction, keep the smoothing to 1, and apply that to the image. For now, I think I'll try with the script, so Seti Astro, automatic DBE, and I'm going to keep the default settings and just click on execute, see what we get. Okay, it tells me that the gradient removal is complete. We can have a quick look at the background using the STF function here. And the background looks fine to me, I think. And then let's do a control click on the STF on the main image that has the background removed. And let's have a look at how it looks like. And that looks pretty good to me. So I'm going to iconize the original image, put it in the corner, maybe rename this one to NA for North American Nebula, and that way we can then keep progressing. Okay, so as I do this, I realize that towards the bottom here, we can see maybe some auto-crop artifacts. So some stacking artifacts are there. So I think what we need to do is actually close this, cancel our automatic dynamic background extraction, and first crop out those artifacts. Because when you have this weird black band, sometimes it's like a band that seems to have more noise in it. If you see that, it's better to remove it before you do the background extraction. So again, as last time, I'm going to search for dynamic crop, and I'm going to click, drag and drop in the image. I can be quite generous with the field of view, but you see I'm making sure that the bottom of the field of view is removed because that's where I see those stacking artifacts. So I'm just going to validate that. I'm going to say yes, it's fine to proceed. And now we have the cropped image, and I can try again the script, Seti Astro, automatic DBE, and execute. Okay, we're done. I'm going to have a quick look at the actual image that was generated. So again, control and click on the STF icon here at the top right, but I'm sure you're starting to get used to this. And I really like what we see here. So I'm going to iconize the original image, and now we're going to keep processing on this. Again, I'm going to double click on the tab on the left and set this to NA for renaming this, and we can keep processing. So my first step, if you have Blur Exterminator, if you've bought and installed Blur Exterminator, would be to run Blur Exterminator. So I'm going to double click on that, and I've seen that because I have so many stars and they're somewhat small, the default 0.5 of sharpened stars is actually a bit too aggressive. So I'm setting it down to 0.2. And then I'm just going to run Blur Exterminator on the image. If you do not have an NVIDIA GPU, an NVIDIA graphics card, this can take quite a while, so don't be afraid to go and grab a coffee or a tea and then come back once the process is done. Okay, and we are done. We can check using the arrows on the top left, the before and after, or we can do it while zooming in, before and after. And I do like what I'm seeing here. And now we can keep going. So my next step would normally be about noise reduction, but remember this image is drizzled, so it has 4 times the resolution as the initial camera image, and it sacrificed signal to noise ratio in order to get more details. But now that we've used Blur Exterminator to extract as many details as we could from that image, we can now sample it down to the size of the original sensor. And I'm going to do that in the Process Explorer, again under All Processes. I'm going to search for Integer Resample. Here it is. So I'll double click on it, and the default settings are actually exactly what we need. We are going to downsample by a factor of 2, and I can just drag and drop the triangle onto the image to apply it there, and now we have the image down to size exactly as we need it. So our next step, noise reduction. Again, we have the choice between 3 processes or 2 processes if you want the free way. So for me, it's Noise Exterminator, which is paid, Graxpert, or Deep SNR. And I find that Deep SNR tends to create stars when there's no stars and it distracts me. So I'm going to avoid Deep SNR, and I'll go with the free one for now, which is Graxpert. So I'll make sure that I have denoising on, the default strength that works pretty well for me usually. And now, just as always, I click, hold, and drag and drop the triangle onto the image to apply that Graxpert process onto it. Okay, and the result is done as a new window here. So I can close the Graxpert process, and our NA image, I can iconize it and put it aside. So now we are with this image. It has been denoised. We can have a look by zooming in, and yes, it's very, very smooth, very, very nice. It's going to be very pleasant to work with. And now it's the time we've gotten the details, we've denoised the image. The image is still in linear mode, so I click on this button here and it just shows darkness. So it means that we should be ready to actually stretch the image to make it to an unstretched state. This is the image that we have right now. By the way, if I do a control click on the STF, it looks like we get a lot of the blue that we wanted from the image, but we're going to have fun differently. I'll show you how we're going to work. So first things first, I'm going to go to Script, Seti Astro, and Statistical Stretch, just like before. We're just going to do a stretch. I can refresh the preview on the right-hand side to see what we are going to get. And this is what we would get. So this is very red image, and this is simply because the nebula is mostly made of hydrogen atoms that emit mostly in the red. This is actually how we would perceive the color of that nebula if we could actually see it like that. And this looks good to me, so I'm just going to execute. Execute order 66. Okay. We're done. I can close the statistical stretch window. This is what we get. And now we're going to do something slightly different, or actually very different than with our simple broadband image of the Pleiades. I'm going to use a process called Narrowband Normalization. And this process, as well as a lot of the tools that I'm using right now, it's one of those tools that we added to the vanilla install of PixInsight. So it's not available with PixInsight by default, but it's one of those excellent free tools. And you can see I open it, and what it will do is it will change the color of the image, not invent colors with AI or anything like that. It's just going to look at the channels, red, green, and blue of the image, and try to map them to more of a palette that resembles like Hubble Space Telescope images, where the hydrogen is red and the oxygen is blue, and we're just trying to get the oxygen a bit above or at the same level as hydrogen. And this is how it looks like with the default settings, and it has that little circle there, which is, if you remember, the real-time preview. So I'm going to open that little circle, and it shows us how the image will look like. And one of the things I forgot about is, okay, if we do it right now, we're also going to change the colors of the stars. But I kind of like the star colors as they are right now, so let's first remove the stars. So again, like before, in our previous processing, I'm going to go in the processes, search for StarNet2, and run that onto the image, making sure that I have this create star mask thing checked. And again, if you're getting tired of going into those processes, etc., remember that you can take the triangle, drag it onto the workspace, and drop it to create icons. You can then go into the icon, say right-click on it, set icon identifier, so I can put like StarNet, and you can run it at any time on the image, and you can save that by right-clicking on your workspace, process icon, and save process icons, and then reload them later on. It's super convenient. Anyway, I'm doing it the slow way around just so that you see every time what I'm doing. So I'm going to run StarNet on this image to see what we get. Aha, I made a mistake. I'm going to pause it, abort it, and yes, you see it told me like warning, linear data option is enabled, but it's not linear data. So I am going to uncheck linear data here and apply it. Okay, and this is the result that we get. So the star mask, we're going to use it later. I'm just going to set it aside. I'm going to close StarNet2, and now we're back to our narrowband normalization process. So again, open up the preview, and this is now what we would get. I can boost the oxygen 3 a little bit, which will boost the blue in the image. I kind of like that. We don't want to go overboard, but this is actually pretty good. And so I can apply it to this image by closing the preview and drag and drop the triangle onto the image just as usual. This is what we get, and now we can play with the colors of this image, and that's going to be interesting because we are going to use masks. You remember masks from the Pleiades? This time we're going to create a mask based on colors. So for that, we're going to go to Script, Utilities, and you want to search for color mask _ mod. So let's click on that, and we get this kind of script. And what we want to do is we want to select the yellow parts of the image because we're going to try to change the colors of the yellow parts of the image. So I'm going to click on yellow here, so that identifies the yellow stuff. And just in case there's some red stuff, I can also change this parameter here, the start hue. And you can see if I make it lower, then this is the range of colors that this will select and create an image based on. Now, because we got to this from the script menu, I cannot use this triangle icon to drop it onto the image. I have to click on OK, and then it will do its job and create an image that is basically telling me the white areas in this image correspond to the areas where you have yellow color in your image. That's what this is saying. And we're going to be using that as a mask. If we use it as a mask as is, we'll introduce some weird noise because you can see the mask is very, very noisy. So the dark pixels will not be protected, but the white pixels will be, so we'll get a lot of grain that will happen with our modifications. So we need to blur this mask first. To blur a mask, we're going to use another process in the Process Explorer called convolution. So I'm going to search for it. There it is, convolution. I'm going to open it, and here it is with the default settings. And the goal here is to make the standard dev quite high. So use the uppermost slider here to make it to like 30, 33 will be good. That should blur our image quite a lot. Let's apply this. Again, triangle, drag, drop. We've applied it, and now things are nice and smooth. This is a color mask that we can use. So I'm going to take the tab on the left, click, hold, drag, and drop to the sidebar of the image. And bam, just like with the Pleiades, we are applying a mask. So this mask is very distracting. I'm going to go to Mask and click on Show Mask to unshow the mask. And now we're going to open the Curves Transformation tool. So again, Processes, Curves Transformation, double click. I'm going to reset it to its settings. And by the way, this is a button that I use from time to time. This resets to the default settings, and you see it in a lot of processes. This is this button that resets the processes. So we're going to do, first, there's the circle here, which is, you guessed it, the preview icon. So we're opening a preview to see what we're doing. And I'm going to go to the green curve. So I'm going to click on that G here. And to set the green, we're going to do an S curve on it, a contrast curve on it. This is just to change a bit the colors that we have selected with the mask. Let's just try to do roughly an S curve. It doesn't have to be very precise. Don't worry about it. And at the same time, we're going to go to the red part of things, and we're going to drag that red up. And look at the kind of result that we get. Suddenly, the yellow areas are getting redder. And we can go back to green and play with the green a little bit if we want. We could say like, oh yeah, I don't want that much yellow. You can see how increasing the green at the top will make things yellow, and decreasing it keeps the red. So this is to taste, really. This operation is very much to taste, and I like what I'm seeing right now, so I can apply it once. Here's what we see on the main image. But you see, I kept the preview open because look at how now it would look like if we apply the same thing once more on the image. I like what I'm seeing, so I'm going to apply exactly the same thing once more to the image to make it even punchier. Should we do it a third time based on this? I don't know. It's to taste. Let me try it. It's fun. Okay, no, maybe I will put the green curve slightly less contrasty, so we smoothen the S out, and the red curve will be slightly less crazy. Something like this. And then try to apply it. This is pretty nice. I like what I'm seeing, and so I'm going to close this image, and don't forget, we have a mask applied, as we can see from that brown color on the tab. So we'll go to Mask and Remove Mask for now. Now we can play with more general curves. So I'm going to go to Curves Transformation again, Reset using the Reset button, and now we go to RGB/K, just like we did for the Pleiades. And we're going to open a preview, just like before, and we can first add points to the curve without changing anything. And then I can say like, oh yeah, the darker areas of the image, I want them a bit darker. Even the midtones slightly darker. Look at how much contrast just doing that gives us. Like the nebula itself pops out from a sea of darkness. I really like that. At the same time, the bright areas, we might make them a bit brighter, slightly brighter. And I love what we're getting here. This is a very smooth kind of contrast curve. And I like what I'm seeing there. This is a lot of fun. Look at what we're getting. So I'm going to apply this curve, maybe slightly less aggressive. It's to taste. That's why curves are in my opinion, the most difficult part of the processing. So I'm going to drag and drop this into the image, and we're starting to see something really beautiful. Okay, now we want maybe to play with the saturation of the image. I want to make that blue more poppy. And there's multiple ways we can do that. We could actually, I think the first thing that I would want to do with that would be to go and create a luminance mask, just like I did before for the Pleiades, if you remember. So I have the image selected, make sure it is selected, and there I can go and click to this little icon there that will create a grayscale version of this image. I can then use this grayscale version of the image, apply it as a mask by drag and dropping the tab on the left to the toolbar area, or that left bar area of the main image. And now we can see that because this is brown again, the mask is applied. And I can go to Curves Transformation again, and if you remember what we did with the Pleiades, I can select this thing here for saturation, open up a preview, and increase the saturation to see what that gives us. Now when we do that, I increase the saturation for all of the colors at once, but that makes the red a bit too poppy. So I'm not going to do that. We're going to use another process in PixInsight. So I'll go to the Process Explorer, and it's called Color Saturation. Here it is. So this process, it basically gives us a yellow line in the middle, and there's some little handles, very tiny handles to the left and right. You can grab a handle, bring it up to make that yellow line higher. Let me open the preview because we have the circle icon here, and this is what this would give us. But you can see it's making the saturation on all of the colors at once. So this is not what we want. Let me reset that using the reset button at the bottom right. And I can go with my mouse cursor. I'll close the preview a moment. With my mouse cursor, I will just click and hold around here. And you can see we have this little yellow cross that appears on the color saturation tool. It tells us what color we are looking at. So the color was roughly here. So what we can do is we can left click on this little yellow line to add points to it. You can see I've added multiple points, and just in the blue we can raise the saturation like that. So let me open up a preview, and this is before and after, and I really like what I'm seeing. Maybe we can apply this once. Oh, nice. And maybe we can apply this a second time. As usual, triangle icon, dragged and dropped onto the image. And I really like what I'm seeing now. Now I can actually reset everything and close color saturation, and maybe go back to curves transformation to do the thing that we did earlier, or that we tried to do earlier, as this saturation curve here. Let's open a preview, and I like what I'm seeing here. It's getting very punchy. And so I'm going to apply this to the image. But remember what we did with the Pleiades? We also wanted to desaturate the background. It's probably not so necessary for this image, but we can do it a little bit. And so I am going to click on this image and go to mask, and then just like we did with the Pleiades, invert mask. And now the bright areas are protected from anything I do. The dark areas will be used. So I'm going to open a preview and decrease saturation. To some extent, if we look at the before and after, it affects the bright areas a little bit, and which is why it's fine to go a little bit overboard with the bright areas. And at the same time, I want a little bit of contrast. So because I've selected just the dark areas right now, maybe I can go to the RGB K curve, and instead of doing a contrast curve, I can just like pull everything down a tiny bit. Not too much, just a tiny bit. This is the before and after. How juicy is this? Oh, I closed the process. That's fine. I closed the process by mistake. If I reopen the process, it remembers exactly what I was trying to do. So no need to get in a panic. So I'm going to apply this. Oops, and I made another mistake. I tried to apply this to the preview. That's not going to work. I'm going to close the preview and apply this to the image itself. And this is what we're getting, and I love what we're getting. This is absolutely beautiful. So now I'm going to close curves transformation. I think I'm done with the nebulosity processing. So I'll make sure, remember we have a mask onto the image. So I'll go to mask and then remove mask to remove the mask. And now we need to add the stars back. So let's go in. Let's go, if you remember, to pixel math, because that's where we can manipulate multiple images at once. So I'm searching for pixel math. There it is among all processes. Double click on pixel math. And we're going to use just like last time, I'm going to actually reset everything. Click on the expression editor. And we want to add Graxpert_denoising. There it is. I'm double clicking. And we want to add this to star mask. Plus, let's find star mask. There it is. Double click. Validate. And now I want to make sure that I'm creating a new image. So I select create new image. It's going to use the same settings as the target. So I make sure that I have this image selected. And then I can click on the little square icon here. And boop, we get the image of the North American Nebula with the stars, and it looks absolutely beautiful, if I say so myself. The stars get a bit distracting, just like last time, so we can use the star reduction method that we had last time. So we'll go to Script, Utilities, and we have star reduction. There we go. Just like last time, we need to select the image with the stars, which is image 50 here. And we need to select the image without the stars, which is Graxpert_denoising. So I'll select Graxpert_denoising. And I really like what the preview is telling me, so I'll just apply it and see what we get. Okay, let's iconize this. Let's open this. And I love what I'm seeing. We still have the stars. They're slightly less visible. They distract from the nebulosity slightly less. And this is the final result. And you can see the whole process is very much on rails. You can use very similar steps or even identical steps for pretty much all of your images, at least for those dual band, narrowband images. And so that's it for this image. The next image will be another color camera dual narrowband image, but this time we'll have both H-alpha oxygen 3 and sulfur 2 oxygen 3, so that we can do a true Hubble palette, and it will be using the very famous pillars of creation with the Eagle Nebula. Okay, now we're ready for the Eagle Nebula. This is a long video. Thanks so much for following through, and don't forget, like the video, subscribe if you're new to the channel, and in which case, welcome. And if you want to support the channel at no cost to you, and you're planning on buying anything from Amazon or buying anything from Agena, First Light Optics, High Point Scientific, etc., if you do so after clicking the links that I have in the description, it will help me out at no cost to you. And if you want to sponsor the channel, you can become a Patreon member. Check the link down in the description. or you can join the channel as a member using the join button next to the subscribe button. Anyway, let's go to the Eagle Nebula. I have PixInsight open, and I have two images to open this time. I have one that was taken with a sulfur 2 oxygen 3 filter, which should be this one, and I'm going to drag and drop into PixInsight. And I have the other one that was taken with an H-alpha oxygen 3 filter, and I'm going to drag and drop. And both of those were taken with an IMX585 color camera. So I have those two images. We can control click on this icon there to do an auto stretch on them, because they are both in a linear stage, so they appear quite dark to us. And we can see that they look pretty decent. Sulfur 2 oxygen 3 is here, H-alpha oxygen 3 is here. One of the things that is very unique to those images, and you probably will not see that on your side, but that if I put them on top of one another, they look almost aligned, except that if you look closely, this pillar is on the wrong side compared to that image. So this image here on the top left has actually been flipped. I'm not sure why, I'm not sure how it happened, but we need to unflip it. So for that, I can go I can select the image, go to Image, Geometry, and Horizontal Mirror, Validate. And now, if I were to rotate this image 90 degrees clockwise, then I would get the same thing as this. But, PixInsight can do it for us automatically. Align the two images together. That's a very important skill to have whenever you're going to combine multiple images. And by the way, this process, along with the sulfur 2, H-alpha, and oxygen 3 process from monochrome camera in this video, is probably going to be the most difficult one and the most open to interpretation, because when we get to narrowband, there's a lot of art that is involved in processing, and I'm personally not very much of an artist. But anyway, this flow should work pretty well regardless. So first we need to align the images together. If you've done the stacking on multiple filters at once, using the weighted batch pre-processing or deep sky stacker, etc., normally your image should already be aligned to one another, not a problem. But if you do the stacking separately, you'll end up in a situation like I have here, where we do need to manually align the images to one another. So let's do it. I'm going to go to Process Explorer, open all processes, and we're going to use star alignment. Star alignment is here, double click, and I need to choose a reference image, which is what we will align to, and then a target image, the image that we want to align with the other, or multiple images, that works as well. So I can click on this little arrow there and select the image that I want to be as a reference. Let's say the H-alpha oxygen 3 image will be my reference. I'm going to validate that. And then I want to align this to our H-alpha oxygen 3 image. So I could add view and select the view, or simply I can actually click and drag this tab on the left of the image into here. And now we've added it. I could have done the same with this like this, by the way. So there's multiple ways we can achieve that. Once we are done, we can just click on Apply Global. This will create a new image for this that will be aligned with this. Let's do this. Okay, and we're done. So we can apply a stretch. And now, if I set one image on top of the other, they line up perfectly. This is exactly what we needed. So I can iconize this. My next step will be to crop the image, because we have a lot of dead space here. So I'll go to the dynamic crop tool that we used in another processing, and I can select my crop here. I need to adjust it so I make sure I don't include any dark space here. And let's say that I kind of like what I see here. So this is the crop that I want to apply. So we need to apply exactly the same crop to this image and to that image. And the way to do that actually is to use the triangle icon. I'll first click and drag that triangle to the image that is not being affected by the dynamic crop. Release, yes, we confirm, and poop, we're applying the same crop as we are going to apply to this one. And now to apply to this one, because it is the target of the crop, I cannot use the triangle, I have to use the green check mark. PixInsight things, right? But once you're used to them, they work pretty well. Okay, and now we do the usual stuff that we did in the other videos. We will remove the background of the images. So I'm going to go to Script, Seti Astro, Automatic DBE, and this one is H-alpha oxygen 3 selected. I'm going to click on Execute. Okay, the background is there. I can stretch it, and we see this is what we get. And I can also check the image once stretched, how it looks like. It looks pretty neat. So I can iconize the old one and right-click on the workspace, select Arrange Icons, will actually put them to the top right where they're out of mind. Then I can do exactly the same thing for this image. So Script, Seti Astro, Automatic DBE. We have the sulfur 2 oxygen 3 image selected, so I click on Execute. We're starting to see a pattern here. We're using the same processes all over and again, the same scripts. So a lot of what we're doing here is completely automated. Okay, so now those images, if you look at the top, they're both drizzled, just like the image of the North America Nebula that we processed earlier. So that means we can resample them to increase the signal-to-noise ratio. That said, before that, if you have Blur Exterminator, you've purchased Blur Exterminator, before you resample, you want to run it. So for me, I go to my Process Explorer, Blur Exterminator, and with these settings that I kind of like, I can click drag drop to apply it to both images. So now we're applying it to the H-alpha oxygen 3, and it's done, and I can go ahead and apply it on the sulfur 2 oxygen 3. And we're done. So now I can resample down to the size of the sensor effectively. So I'll go to Process Explorer, just like we did for the previous image. Go to Integer Resample, double click. The default settings will work. So I can just drag and drop to each of the images, and we are done. This is how they look like. Next step, I'll do something pretty interesting. I will do a stretch of this image, extract the stars, set them aside, and then undo what I did. This is basically so that once after everything is done, we can add back the stars to the image, because very soon we're going to remove the stars so we can process the nebulosity on its own. So let's do that. I am going to go to Script, Seti Astro, Statistical Stretch. I'm going to just execute because I don't really care how well the stretch works. And then I can use either StarNet or Star Exterminator. So I'll use Star Exterminator this time. I think last time I used StarNet, but it's the same thing. We want to generate a star image. I'm going to check unscreen stars as well. If you're using Star Exterminator, if you're using StarNet, you don't have that option. Don't worry about it. And I apply this to the stretched image. Okay, it's done. Now we have our star image. What I'll do is on the tab on the left, I'll double click. That lets me rename the image. I'll call that stars, iconize this, and set it aside. Now that we have a star image, I can just go back to preview prior to the stretch. And now we're back to exactly where we started, except that we have a star image that we'll be using at the very end of our process. This is just thinking about the future. Next, we can apply some noise reduction. I've seen that on drizzled image that have been sampled down again, the Graxpert process with the latest AI 3.0.2, even at high strength, can work pretty well. So I'll be doing that on both images, although it is very, very slow. So I will get back to you once I've applied Graxpert on both images. And we are done. We have our new denoised images on both sides. So I can iconize the old one, and right-click on the workspace, arrange icons to put them out of sight, more or less. Those names are really long, but whatever. And now I'm actually going to go ahead and remove the stars from both images. So this time, let's say I will use StarNet. Why not? We don't want to create a star mask. The data is still linear, so I'm just going to apply to both images. And so drag and drop the triangle on each, and now we remove the stars. And later, further down the line, I'll be able to place them back using the other one that we've already created. Okay, now this is starting to look pretty neat. So my next step is I'm going to go to Script, Utilities, and use dbExtract, which is one of the scripts that we installed together at the very start of this video. And what this script will do is it will take those color images and extract hydrogen alpha, sulfur 2, and oxygen 3 images out of it based on your camera. So I have this camera sensor IMX571, but no, those were taken with the IMX585 sensor. So this is what I'm going to select. My H-alpha oxygen 3 image is this one, the red one, so that is Graxper denoising with the trailing 1. And my sulfur 2 oxygen 3 image is Graxper denoising without the 1. Here we go. And I can click on Extract. Once we're done with the script, I can close the script window, and we have multiple images created. We have hydrogen alpha here, we have sulfur 2 here, and we also have oxygen 3 here. And we also have, if I control click here, an SHO image that we could use, but I'm not quite going to do that. I'm going to iconize it for now. And we're going to use those 3 images, and I'm going to stretch them all. So I will go to Script, Seti Astro, Statistical Stretch, and I'll select H-alpha, and I'll do a preview refresh. But you see that at 0.25, the core is very, very bright. I want to avoid that, so I'll try 0.2, preview refresh. This is a bit more like what I want, so I'm going to click on Execute. And we also want to apply the exact same stretch with the same parameter to sulfur 2. I'm going to click on Execute, and to oxygen 3. I'm going to click on Execute. There we are. Now I can combine those channels. And for that, I'm going to use the LRGB combination. Here we go. And we have LRGB. And I'm going to put the oxygen 3 into the blue by drag and dropping the little tab here. I'm going to put the H-alpha into the green. And I'm going to put the sulfur 2 into the red. And then we have luminance. And for luminance, I like to use H-alpha because it typically has the most amount of details. And it's basically this L here, luminance, it's kind of a details channel. So I like to add it. And then this is the Hubble palette with sulfur 2 in red, hydrogen in green, and oxygen 3 in blue. And to apply this, it will create a new image based on all of those images. And I'll just click on the Apply Global to create that new image. And here is what we see as the new image. So now I can iconize the initial SHO images. Bop. Right click on the workspace, arrange icons, and I'm also going to do something else. I'm going to rotate this image to a point of view that I'm more used to for the pillars of creation. This is pure personal preference, but I can go to Process Explorer, Rotation, and set an angle here of 180 degrees. So we're just going to rotate by 180 degrees and click, drag, drop to apply to this. Now this is an angle I'm more used to. That's just personal preference. And now we can choose how to process this image. There's multiple ways to process SHO images like that. We could go to a tool called SCNR. We used it on the Pleiades earlier to remove the green. And you can see if I apply a CNR to the image, we get some classic color palette images, and that's a very valid approach. Or I can undo that and use the Narrowband Normalization tool that we used for the North American Nebula earlier. So I could go to Process Explorer, Narrowband Normalization, and in here I need to make sure that the palette that I select is SHO, because this is what we have created, a SHO palette image. Once it's selected, I can click on the preview, see how it looks like, and I can play with like the Sulfur 2 boost and maybe reduce it a little bit because it's a bit too aggressive. There we go. I kind of like what I'm starting to see. And maybe I want to increase the Oxygen 3 boost or decrease it. Basically, we need to find the right parameters for an image that looks kind of nice for us. But that's one of the things that I find very difficult with narrowband images is this combination and playing with the colors. So if you are finding this difficult, don't worry. This I do as well, but you can see that these scripts and tools can help us, have the least amount of issue with the image. I think this is fine. So I'm going to close the preview and just apply this to the image. And those colors, they do look pretty nice. Okay, next step is we have a very bright core of the nebula. So maybe what I can do is go to Process Explorer, HDR Multiscale Transform. Remember, I showed you that with the Pleiades. And in there, you just want to click on 2 Intensity, Lightness Mask, and try to apply it to our target. And I actually really like what it did. This is the before and after. You can see now the pillars of creation are much more visible than they used to be. By the way, you can see those purplish areas. Those are leftovers from the stars removed by StarNet. Fun fact, if we had used a star exterminator instead, that paid version of a star removal tool, you would not see those purplish kind of things. If those purplish spots bother you, and they kind of do me, you can remove them using a very weird technique, which is to go to Process Explorer, invert the image, which you can just double click and it inverts the image, and now those blobs are green. Remember, we have a tool that can remove the green. Yes, we can go to Process Explorer, SCNR, and here it is, and just remove the green, and then invert the image again. Process Explorer, invert. And now we've removed that slightly unpleasant magenta image. You wouldn't have to do that if you had used Star Exterminator. So that's just a fun thing about this. Now we can do exactly like we did for the North American Nebula. So I can go to Script, Utilities, Color Mask _ Mud, and just like last time, we're going to select the yellow, maybe a little bit of the red as well. So I'm going to change the start hue to be more around here and just validate that. And now we have selected the yellow. We get a mask that we could apply, but just like last time, we're going to do a convolution. Convolution is basically going to be used to blur the image. So I've opened the convolution tool from the Process Explorer. I can use the top slider just like we did last time to have a fairly high value, 30 something, and then apply it to the mask. So we have completely blurred the mask. If we lose a bit too much detail on the mask, we could go to 28 and see what happens. You can adjust that. Actually, I prefer 28. So I'm going to use that. And now we can click on the tab, drag and drop on the little sidebar here, and apply the mask to the image. As usual, it's very disturbing. Everything becomes red. So I can click on the image to select it, go to mask, and unshow the mask. Okay. Now that the mask is applied, we can see it with the brown here, and we can see what we're doing. I can go Process Explorer, and do you know what I'm going to do? Curves transformation, just like in the North American Nebula. I'll double click on this, open a preview, select the green channel here, and we're going to do somewhat of a contrast curve. Pop. And then I select the red channel. And this time I just want to increase the red channel. And we can see before and after. And I could apply exactly this curve multiple times in a row. So I could click on this apply to target, boop, and apply to target again, so that we get more and more of that effect. You can see. Boop. Okay, I think I'm done. This is probably good enough. And now we could remove the mask, remove mask, and maybe we want to work on the blue a little bit. We could try. So for that, I could go to Script, Utilities, Color Mask Mod, select the blue. I'm going to adjust the start hue to select a bit the cyan color as well as cyan, I guess is the name of the color. Click on OK. This will create a mask with all of the blue and the cyan. Now I will need to blur it out. So yes, we go back to convolution. It's remembered the previous settings, they're fine. So I can click, drag, drop the triangle to apply it to the mask. And I can apply the mask to the image. And again, I can go to Curves Transformation. It's still open, so I'm just going to reset the process using the bottom right button. And this time, I'm going to try something interesting. I'm going to go to red, green, blue, which is the overall luminance of the image, and try to first open a preview and then drag the curve down. And that darkens the blue and makes it kind of more punchy in some respects. And the nebula, the pillars of creation, are also better visible that way. We could play also with the blue channel, you know, up, down, depending on what you like. And this is really the art part of the image, or, you know, not do anything. So for me, I'll just do this RGBK kind of slightly lower, and that's it. That's all that I'm going to do. And just apply to the image. Now we're starting to see something that is really, really nice. We have the mask still applied, so I want to make sure I have the image selected. Click on Mask, remove Mask, and now I can reset the curves, open a preview, and maybe do a simple contrast curve. Or, you know, I'm going to add those 3 points there to keep the curve kind of as is and say, okay, the dark areas should be a little bit darker, maybe this as well. The bright areas can be a tiny bit brighter, something like that. And that looks pretty nice. I can apply this using the square icon or drag and drop the triangle to the image. Close the preview. This is what we're getting now. And I could do some color saturation as well. Remember what we did for color saturation last time? We took the image, extracted the brightness from the image as a color, as a monochrome image, and we can apply the monochrome image as a mask to our main image, and then we can go to curves, reset the curves, go to the saturation, open a preview, and we can saturate a little bit. There we go. This is really to taste. Try not to overdo it. I think I'm overdoing it a little bit. I'm still going to apply it to the image. And now, just like we did last time, I'm going to go to Mask, Invert Mask. And this time, opening the preview, I'm going to drag the saturation down so we desaturate the darker areas a little bit. And apply this to the image. And I think I'm good with this image for now. So now, remember how much earlier in this process we extracted some stars. Now we can place them back. Before I do so, I noticed that the stars are a little bit green. What do we do when we have green stuff? We can remove it using, drum roll, where is it? SCNR. Here's my SCNR. I'm actually going to apply it on the stars to remove the green. And now we can place the stars back. As I recall, we used Star Exterminator with the unscreen tool. So I'm going to show you the formula that we use to combine that back. If you use StarNet, it's going to be a simple addition. But because I used the unscreen star option of Star Exterminator, it's slightly better. And I can use pixel math. So again, remember, Process Explorer, Pixel Math, I'm going to set expression editor. Oh, and I notice before I do that, I'm going to close that. I need to make sure that this image does not have a mask. So I'll go to mask, remove mask. Whew, we dodged the bullet there. Go back to expression editor, and I will I will program tilde, open brackets, open another bracket, tilde again, and I want to select image 83, double click, and then multiplied by open brackets, tilde, and now we'll select my star image, double click, close brackets, validate. This will add back the stars. If you had used StarNet, you just have image 83 plus stars, right? So it's a much simpler but slightly inferior result. Not a big deal. You want to check the destination. We're going to say we want to create a new image. It will be the same as target, so make sure that you have image 83 selected, and then click on the square icon to apply to target, and bam, there we have our image with the stars. And that's more or less our final image. Just like last time, we could reduce the impact of the stars. So if I wanted to, I could go to Script, Utilities, Star Reduction, and I want to select the target view would be image 87, and the starless view would be image 83. And I can validate. It will anyway create a new image so we can compare the old image from the new. I'm going to close the process, iconize this, and yeah, we can choose either the image on the left or the image on the right as our final image. I kind of like the image on the right. I think I went a bit too far with the saturation, so maybe I could go to my curves transformation. Here we go, and maybe apply a desaturation to the whole image. Whatever works for you. Maybe this level of desaturation, right? That's where things get really artsy and we're just making pretty pictures. But this is what we get with the pillars of creation from the Eagle Nebula. And it's not the best image ever, but it's pretty nice. And you saw that we reused again a lot of the scripts that we have used. And we are done with this tutorial for the one-shot color cameras. Now I have two more to do for monochrome cameras using LRGB filters and using sulfur 2 H alpha and oxygen 3 filters, although the latter will be pretty much exactly what we did here. Okay, now we can go to our next scenario, monochrome LRGB, and I'm going to be using some M101 images that I took over 4 years ago now, back when I had a monochrome camera. And so I can open blue, green, luminance, red, and there they are. So as usual, each image opens the main image together with like some high and low stuff. You can see in the name, high and low. We're just going to close all of that. So high, low, they're gone. High, low, they're gone. High, low, they're gone. High, low, they're gone. We have luminance, red, with the red R, L for luminance, green, blue with the B, and then green. Here's what we have. We can apply a screen transfer function to see what's going on each of those images. Okay, looks fine. And we can see, are they aligned? Yes, they seem to be aligned to one another, so I stack them all together, which is good for me. So we don't need to use the star alignment tool that we used with our narrowband example earlier with the Eagle Nebula M16. If you do have to align those images together, you can use the all processes and go to star alignment. But basically you'd choose a reference image. So let's say we want to use L as reference image. I can drag and drop L to this field, and then the other images, I could drag and drop them into this list, and then click on Apply Global to align everything together. But the whole process is in my previous image processing, which was on the Eagle Nebula. Okay, so now that we have all of those images, I can see there are some stacking artifacts. Anyway, the main target here is the middle of the field of view. So I am going to go to my favorite tool, the dynamic crop, at the start of the process. So I'm going to use the Luminance channel as my reference for dynamic crop. Let's say we're going to have something like this. So we have the galaxy well centered, but I have another galaxy here. I want to keep it. Okay, let's say let's say something like this. Okay, I kind of, oh, whatever. Let's have the largest field of view we can while removing the stacking artifacts. There we go. Okay, this is what we go with. And now, just like we did for the Hubble palettes image with the color camera, I'm going to use the triangle icon to apply this crop on all of the other images. Pop. And then finally, I'm going to click on the check mark to apply it on the main image. Okay, now we have 4 different images. We're on Rails. We're just going to do the usual stuff. I'm going to close dynamic crop. I don't need you anymore. I'm going to go for, let's do Grexpert for removing the background. You can use Seti Astro as well. That works just as well. I'm just, switching between the two depending on what you like. If you set a smoothing of 1 on Grexpert, it should always work pretty decently. So I'll just click on replace image there. I don't want to create a new image because I'm too lazy to clean up the images. And I will apply this Grexpert background extraction with the smoothing of 1 on each of the channels that I have. And now it is done. I've applied Grexpert. So what's my next step? Well, we can do, if you have it, blur exterminator to extract as many details as we can and to also tighten the stars. So I'll go, where is my blur exterminator? Here it is. Fun fact, if you want to apply a single process to multiple images at once, you can click on the workspace, go to image container, then you can add all of these images by drag and dropping into the image container. Pop. So we drag and drop the tab icon on the left of the image. And then you can do something weird, which is to drag and drop the triangle icon of your image container to the bottom bar of the process you want to apply to all of the images in that container. And then it will do everything on all of those 4 images. So I wanted to apply blur exterminator on the 4 images. I can use an image container for that. You don't have to use that. It's just a little additional tip. Otherwise, I would just have drag and drop the triangle on each image, one after another. But here, everything's automated, and I do like being lazy. Okay, we've applied like that noise exterminator on all 4 of those images. And next is I will want to apply some noise reduction on each of those images. So you could use Grexpert, for instance, or we could use star noise exterminator. I'll go with noise exterminator. Feel free to use Grexpert. And again, I can actually go to my image container, open up noise exterminator, but for you it could absolutely be Grexpert with the noise reduction selected. You should be used to it by now. And I'm just going to drag and drop the little triangle icon from my image container, click on the drag and drop it to the bottom bar of noise exterminator, and now noise exterminator will just run on all of those 4 images. It's completely automated, and I kind of love that we're able to do that. Okay, the noise removal is done. My next step, I think, now we do something special. We are going to combine the red, green, and blue channels together, but we are not going to change the luminance channel yet. For now, I'm just going to double click on the luminance channel, call it L, so I remember, and we're going to go to Process Explorer and go to a process that is called channel combination. There it is, channel combination. I'm going to open that, and this is a process, this process is on Rails. You will do exactly the same basically for any LRGB image that you took with a monochrome camera. That's what I love about this. So this is the green image. I'm going to drag and drop it to the green field with the tab on the left, just like we did for the SHO image that we did earlier. The red image, drag and drop it to red, and then the blue image, drag and drop it to blue. Keep all of the options the same. it will create a new image, so just click on the Apply Global button. Here's the new image that we created. Everything is still in the linear mode, so I'm going to do a control click on the STF to see what we see. And this looks pretty nice actually. So I'm going to actually iconize all of those RGB images, right click on the background, arrange icons, now they're in the top right, out of sight, more or less. And if I do shift click, you can see I have like a weird background. So we are now going to do just like we did with the Pleiades. And so because we have that, and actually at any rate, what we always want to do, we're actually almost back on Rails, just like the Pleiades nebula that we processed earlier. Now I can go ahead and do a spectrophotometric color calibration. To do that, first, we need to make sure that the image is solved. So I will go to Script, Image Analysis, ImageSolver. And if you remember, we did that for the Pleiades. And the good thing about this is that it uses the metadata that is in your image. And for me, I do have metadata. So I actually do not need to go in there and search for M101 and then select it, which you could do if you needed to. And I don't need to set my focal length pixel size because all of that is data that is embedded into my image. So I can use it as is and click on OK. If you haven't got it in your data, you need to set that exactly as I showed during the Pleiades processing. I get a warning, we can ignore that, click on yes, and we are done. So now that the image is solved, I can go to Process Explorer, and this is exactly like the Pleiades. I'll go to Spectrophotometric Color Calibration. It's important to run that while the image is still linear. That's why everything is still linear right now. And just like before, I'm going to still do control-click on the image to see what I'm doing. I'm going to open up a preview, select an area of background, and we can set a region of interest. This is exactly like in the Pleiades. And click on From Preview and select the preview and click OK. We could also, by the way, take the preview, grab the tab, and then like drag it onto this checkbox. PixInsight is weird like that. There's tons of super convenient ways of doing things, but they're not intuitive. But once you're used to it, it's super convenient. Anyway, now that we're done, I can drag and drop the triangle onto the image. And once it's done, we see the result, and we see a lot of stars are well aligned on those lines, so we should have a good result. Now I can look at the image. This time I will do a shift click for linked stretch onto the image, and this is what we see. This looks really, really nice. The corners are a bit dark, so you know what? I'm going to try running Gragspert again. Whenever you see that, you have an uneven background, which is very visible on a galaxy image, you can go Gragspert or Seti Astro, and yeah, smoothing of one, I'll just drag and drop on here and see what we get. It's actually a bit better, but the corners are still not perfect. And so because the background inconsistencies are still a bit there in the corners, I'm going to use our favorite tool, Dynamic Crop, and maybe have something like this with the galaxy more or less in the center. Let's see, yeah, that way we completely avoid the issues on the side of the image, and I can keep that striking orange star that we have here. Before applying it, I need to make sure that I apply it to the Luminance image first, and then to the red, green, blue image. I can validate this, say yes, and we are good. Now we need to combine the Luminance to the color image, but not yet. Now I'm renaming the color image to RGB, just to remember what I'm doing. The combination of a Luminance channel with an RGB color channel can only be done on stretched images. And those are, if I click here, unstretched. Both of them. So, thing to do is to go to Script, Seti Astro, and Statistical Stretch. And for LRGB, I would highly recommend not going to 0.25, but to something like 0.20 or even 0.15. Let's apply actually first on the Luminance channel. And you can see the preview, how it looks like, and the core of the galaxy is not too bright. I think this looks fine. So I'll do 0.20. But this is something where you want to be very careful about the core of the galaxy. And if you ever see, after combining the luminance with the RGB, that the core of the galaxy or some bright areas of your images are like basically too bright, you cannot recover details, then you can go back to your stretching step and then do the target at 0.15. I could even try what it does at, actually I like 0.15. Let's go with 0.15. I'm going to apply that to the L, and then I'm going to apply exactly the same thing to RGB. Okay, and now that we have both of our images stretched, we can combine the two together. But if you'll notice, the luminance channel stars are a bit fatter than the RGB channel stars. And that's normal because luminance includes all of the band passes at once. So one of the things that we can do is go to Star Exterminator or StarNet++. Let's do Star Exterminator. And we want to make sure that we have a generate star image set. If we were using StarNet, we'd have the create star mask checked. Apply this to the RGB image. Okay, now we have this image. I'm going to rename it by double-clicking on the tab to stars, iconize it, and we'll get back to it later. Now I can uncheck the generate star image, or if you're using StarNet, uncheck create star mask, and apply that to the luminance image. And now we can apply the channel combination. So one of the easiest ways is to just go to LRGB combination, the tool that we used for the one-shot color SHO Hubble palette. And you can uncheck red, green, blue, and you can drag and drop the L tab into this field, or simply use this drop down here and select the L channel. And by basically taking this and applying that to the color image, what we're saying is add to the color image the luminance channel that we have here. So let's do it. And bam, this is what we get. This is the before and after. Note how much more details we have because the luminance channel with the UVIR cut filter always has more details. You'll also notice that in the before and after, everything in the image became much brighter. And that's why I stretched only to 0.15 this time to avoid saturating pixels effectively. If you see that when you do this, you still have saturated pixels, you can go back to the stretch. Or maybe if you have like an image with a very bright core, like M42, for instance, then before applying this channel combination, you could do HDR multiscale transform. This tool here, where you have 2 intensity, lightness mask, keep the default settings and try to apply it. That would help with the overbright core if you ever run into this issue. Now we're back on Rails, right? I can iconize the L image, go for arrange icons, close StarNet as well, and I can play with this image. So I can go to curves transformation. In there, I can play with my RGB/K curve, open a preview. Maybe we want to decrease, increase the darkness of the background while keeping the nebulosity of the galaxy. We do want to be very careful about that. So you see very small changes all over. I could potentially increase a little bit the mid-tones there, increase a little bit the bright areas, very small changes. This is before and after. This looks pretty nice. I'll apply it to the image. And now we could play with the saturation of the image. Before that, maybe I can do another layer of noise reduction, see what happens. We can try, it doesn't hurt to try. Let's see what Graxpert could do with the latest AI model. I'm going to try to apply it, see what the result is. Okay, and Graxpert is done. This is the before, this is the after. It did a very, very good job. Before again, after. Okay, I really like that. And now I can use this image and, I'm gonna extract the luminance. So click on this button here, and I'm going to apply the luminance as a mask on the image. I mean, you know the drill, right? So probably your image would look suddenly super red like this. I'm just going to click on mask, show mask, and then I can go to curves transformation again and reset everything. Go to the saturation side of things, click on the preview icon, increase the saturation for the bright areas of the image thanks to the mask that I have, and then I can use the square icon to apply to the image, apply again, apply again. Basically, we keep applying, and each time the saturation becomes a bit more. I think this is enough, probably actually even a bit too much, but whatever, I'm having fun. And then I can, go to mask, invert mask, reset the curve, open a preview, and it's probably not super necessary this time, but we could slightly decrease the saturation of the background. Boop, and there we go. We have what I believe to be a really awesome image. This is much better than when I last processed it. The core is a little bit blown out. So be it. So I can go to mask, remove mask, and now we're going to place back the stars that we saved here. They're here, those stars waiting for us. So I think I used Star Exterminator with the end screen. So I'll go to Pixel Math. Remember that if you were using StarNet, you'd just have like RGB plus stars. So the name here is RGB plus the name here is stars. For me, it's going to be tilde, brackets, tilde, RGB, times, brackets, tilde, stars, brackets, brackets. There we go. Then I go to destination, create new image, select the image here, click on the square, and here we go. We have almost the final image. And then we can do the usual again. Go to script, utilities, and star reduction to make the stars slightly smaller. My target view is image 27. My view without stars is RGB. And that removes or actually lessens the impact of a lot of the stars there. And let's see what the end result is. And I really like what I'm seeing here. We have now processed an LRGB image taken with a monochrome camera. And I really, really, really like the result that we are getting. FYI, the last time that I processed this image with my skills at the time, this is what I had achieved. I much, much prefer this result. There we go. We're done with this image. And next we'll have the final image that I'm going to process, which is a monochrome image with sulfur, hydrogen, and oxygen filters. And the process is actually going to be almost exactly the same as what we had with the one-shot color camera with SHO, except that we don't need to deal with color images and separating the channels at first because the channels are already separated for us. So it should be very familiar to you. And let's remember, SHO images are, in my opinion, the most difficult process. They are where we are the least on Rails. So just take that into account, but still, all of the scripts that we have in PixInsight will help us really process the image without too many issues. Okay, and for our last image, again, monochrome camera with HSO filters for the Hubble palette, we're going to do the Rosette Nebula. So I'm opening my pictures right now. There they are. They are already aligned to one another, but we had quite a bit of rotation between filters, so I'll have to crop a lot. So let's start. It's kind of like the same as usual, so we're going to go to dynamic crop. I'm going to use, let me close dynamic crop and open it again. I am going to use this image as the reference. Let's see, something like this is fine, like the heart of the Rosette Nebula. Boop, we apply it to sulfur 2. Boop, we apply it to H-alpha. And boop, we apply it to our original image. So that's the field of view that we end up with. I'm going to close dynamic crop. So again, this is the usual stuff, right? So we use the triangle to apply to the other images before the checkbox to apply to oxygen 3. Okay, next I'm going to create a container, image container. Right click on the background, click image container, and now I can drag and drop the tabs on each of the images to the image container. And I want to do a few things. I want to do blur exterminator. If you have it, it's the right time to do it. So we can go to Process Explorer, Blur Exterminator, and just like I showed earlier, I can drag and drop the triangle of the image container to the bottom bar of any process, and that will automatically apply it to all 3 images. So let's wait until it's done. Okay, and we're done. Now we can go to the next step. Let's see, I probably want to do some noise reduction, but as you can see from the image file name, we have drizzled this image. So first I am going to resample it to its original image scale. So as before, we're going to search in the processes for integer resample, and we're going to use the default settings on all 3 images. So again, from the image container, drag and drop the triangle to the bar of the process we want to apply, and immediately it is applied to all 3 images. Excellent. Next step, I'm going to do some noise reduction. So I'm going to use noise exterminator. There we go. Default settings are my usual settings of the noise of 0.6. Drag and drop the image container triangle to noise exterminator. This is really paradise to apply all of those processes to the 3 images at once. We're done. Oh, and I forgot about background extraction. So I'm going to open up Graxpert process. We're going to select background extraction. Make sure the smoothing is at 1 unless you have a very difficult background. And we have checked replace image. I'll apply, same method as always, and it will apply to all 3 images. Let's wait for it to be done. And we are done. So that's all of the prep really needed before we go from the linear state that we are in right now. If I set up the STF to remove it, then we can see we are still in the linear stage. And now my goal is to stretch those images. So just like always, I'm going to go to Script, Seti Astro, Statistical Stretch. And just like with the one-shot color camera with SHO or with the LRGB combination from Monochrome, I'm going to diminish the target median to 0.15 for now. I'm going to click on Preview Refresh to see what it looks like. That looks fine to me. And we are going to click on Execute. Right now we're doing it for H-alpha. Let's do it next for Sulfur 2. Execute. And then for Oxygen 3, Execute. The image is no longer linear, so we can do exactly like we did with the SHO image via the color camera on the Eagle Nebula. I can go to LRGB combination. Where are you? There you are. And we're going to have exactly the same as for the previous SHO we did. I'm going to put H-alpha in the luminance, also in the green. We're going to put Oxygen 3 in the blue, and we're going to put Sulfur 2 in the red. And, well, I'll check chrominance noise reduction, why not? And then click on Apply Global. This will create a new image as this combination in the Hubble palette. We're really like on rails, right? And this is what we get. It looks pretty cool. The images, the stars are very magenta. That's fine, that's how it is. There are ways to like take RGB stars and include them. I'm not going to bother with this for now. I'm just going to go to Star Exterminator. Could use StarNet as well. And just remove the stars for now. There they are. They're still very magenta. So remember what we did previously to remove magenta? I can invert the image. Now the stars are green. I can then open SCNR that can remove green and apply SCNR to the image. And invert again. And now the stars are no longer magenta, so much more natural looking stars. I'm going to rename this by double-clicking on the tab to stars and iconize it. You notice that I'm going faster than before simply because by now I think you've got the grips of it. So I'm iconizing everything I don't need, right-clicking on the background, arrange icons, it's everything on the top right. And now I'm going to go for narrowband normalization, just like we did with the one-shot color image. So where are you, narrowband? There you go. Narrowband normalization, just like we did for the color camera. I'm going to select SHO, and let's have a look at how the image would look like. That's actually pretty nice. I might increase a little bit the oxygen 3 boost and decrease a little bit the sulfur 2, and that looks fine to me. So I can apply it to the image. Boop. Here we go. Now, just like before, we can use some color masks. So, script, utilities, color mask mode, yellow, and we extend the start hue to include some of the red. Click OK. We're really on rails, aren't we? Now I want to blur out the mask, so I go to Process Explorer, Convolution. In Convolution, we use the top slider to go to like 29, 30, something like that. Apply that to the mask to blur it out. Then we apply the mask as a mask to the main image by dragging and dropping the tab on the taskbar at the left of the image. Then I select the image, click on Mask, Show Mask, so we see what we're doing, and I open my curves transformation. Here we go. I go to green to do a contrast curve. I open a preview using the circle icon, and contrast curve will look something like this. At the same time, I go to red and I increase the whole curve like that. And that looks pretty sweet. I like it. Let's apply. Boop. We're good with the application. Next step, let's try to see what we can do for that blue, if there's anything we can do. Doesn't hurt if it doesn't do anything. I'm going to remove the mask from the image. And now our script, utilities, color mask mode, select blue, and we're going to extend it to cyan. So I'm going to change the start hue to be like, yeah, around here. Click on OK. And just like before, I'm going to apply the convolution to our mask. Apply this as a mask on the image. We can double check by show mask. It is definitely applied. And now we can open curves transformation and see if there's anything interesting we can do. Open a preview, blue color. We can increase or decrease to taste. And RGBK, we can increase or decrease to taste. I kind of like this. Boop. And we can apply to the image. Now I can reset the curves, remove the mask from the image, and we could try a simple, contrast curve as usual. So I'm going to add my points and say like, yeah, the background, we can reduce it a bit to isolate the nebula from the rest of the background. And let's see, midtones. Yeah, that's good. High tones. That looks decent. And we can apply that. Pop. We're making some good progress there. The background has a bit of color in it, so we can play with saturation just like we did before. Remember how we do that? We create a black and white version of the image by clicking on this button here. Once it's done, we apply it as a mask. We love masks. Then I open Curves Transformation, reset everything, go to Saturation, open a preview, increase saturation. Let's see, before, after. This looks nice. Apply to target. Let's try to apply a second time. And then now that would be too much, so I go back to Mask. And then I do Invert Mask. This time we're going to apply the color saturation to the background effectively. So I take my saturation, put it down, and see how the result looks like. And yes, we are definitely removing some of the color from the background. This is exactly what we wanted. So I can apply this to the image, and we're getting towards a point where the image looks real nice. There's a bit of magenta there that I'm not such a huge fan of. I think it comes from the stars that were originally in the image. So what we could try, not sure if it's going to work, but we can use the invert trick. Before I do anything, I want to remove the mask. So remove mask. Then we'll try the invert trick. Double click on invert. Try to remove the green. Double click on invert again. Let's see. This is before. This is after. I kind of like the before better, actually. So let's not do this. And I guess next we can replace the stars back into the image. So as usual, let's go to the processes. Let's go to Pixel Math. Pop. And in there, I can rename, yeah, no, that's fine. I can even type things. Usual formula for me, if it's Star Exterminator. For you, if it is StarNet, it's just a plus. You'd be doing image 13, because that's the name of the image here, plus stars, because that's the name of the star image. For me, I used Star Exterminator with the unscreened stars, so I'm going to do the tilde method. And that's it. Destination will be a new image. We're going to click on Apply Global, no, sorry, Target after selecting this. So on the square icon, and bam, we have our almost final image. We could try to make the stars slightly less noticeable. It's completely up to you. So for that, as usual, Script, Utilities, and where was it? Star Reduction. In that, image 18 is our star full image, and image 13 was our starless view. We can apply it, see how it looks like. And I do think it looks really, really nice. So you can see this time I went a bit faster on purpose, and you can see how quickly we can go through the whole processing flow in PixInsight. And at the same time, we're pretty much almost on rails. We can do some improvisation here and there. Curves are difficult, but otherwise, we are mostly on rails. And once you're used to PixInsight, it's really something you cannot do without. I mean, Photoshop, you can probably do most of what PixInsight does, but I think PixInsight is really the reference, and I do not regret 1 second spending the dough to buy PixInsight. It is the one piece of equipment that I've used throughout the years and that I will keep using throughout the years. My best Astro investment, seriously. So yeah, this has been a very, very long video, I'm sure. So thanks for sticking with me. I hope it made you a master at PixInsight. Let me know down in the comments how you liked it and whether it has helped you. While you're going there, don't forget to like the video. If you're new to the channel and you like astrophotography and you like such tutorials, how-tos, equipment reviews, you may consider subscribing. If you want to support me and you're planning on buying anything from Amazon or from Agena, High Point Scientific, First Light Optics, etc., have a look at the links down in the description. If you buy anything from those sites after clicking the links, it will help me out at no cost to you. And if you want to sponsor the channel more directly for those titanic amount of work that I had to do for this video, you can join my Patreon as a supporter. The link is down in the description. Or you can join my channel as a member using the join button next to the subscribe button. And you guys, you know it. You make the channel possible. This video is possible because of you. So thank you so much as always. Because this has been a relatively long video, I will be leaving the credits with my Patreons and channel members at the end of this video. Yeah, with that again, I hope it has been useful. I hope it will make you a master at PixInsight, and I hope it will, give you the impetus to try out that PixInsight trial, which is free for 45 days, and maybe even buy it in the future, because I'm certain that this is the best way to get, really good at post-processing, and it's a critical skill in this hobby. So thank you so much for watching. Don't forget, whenever you can, to look up at the stars, and I'll see you next time.